Hi everyone and welcome back to the channel. My name is Martin Yanev, a software engineer and a computer science professor at Fitchburg State University. And today we are going to learn how we can use together Vue.js and TypeScript to build great and maintainable applications. I will show you the best practices in state management, component design and type integration, so after the end of this course you can expect to be able to build end-to-end applications using the most modern technologies like Vue.js and TypeScript. The full code for this video is going to be linked in the description. Make sure you subscribe my channel for more similar videos like this one. And now let's get started.
Alright, let's dive into the fascinating world of Vue.js, a modern front-end framework that has quickly gained popularity among developers. By the end of this video, you'll understand what Vue.js is, why it's important, and how to get started with building your own interactive applications. So let's get into it. Vue.js is an open-source JavaScript framework designed for building user interfaces and single-page applications. What makes it stand out is its simplicity and flexibility. Whether you're a seasoned developer or just starting, Vue's gentle learning curve makes it accessible for everyone. Unlike some of its counterparts, Vue doesn't require a deep understanding of complex concepts to produce amazing results. Vue's core library focuses solely on the Vue layer, making it perfect for integrating with other libraries or existing projects. It's also powerful enough to create sophisticated single-page applications when paired with modern tooling and supporting libraries. Imagine wielding a tool that's lightweight yet capable of handling large-scale projects with grace. That's Vue.js for you. Now let's talk about the benefits of using Vue.js. First off, performance. Vue is designed from the ground up to be performant. It utilizes a virtual DOM that ensures updates to the actual DOM are minimized, which keeps your applications running smoothly. This is especially crucial as your applications grow in size and complexity. Another major selling point is its ease of integration. Vue can be added to projects incrementally. If you have an existing application and want to enhance it with a bit of interactivity, you can introduce Vue without a complete rewrite. This flexibility makes it incredibly useful for projects of all sizes. And then there's the community aspect. Vue.js has a rich ecosystem of plugins and tools contributed by developers worldwide. This means that for almost any feature or functionality you might need, there's likely a library or plugin available. Plus, the supportive community is always eager to help newcomers through forums and online resources. Now let's verify that Node.js is installed correctly by checking its version. To do this, we will open our terminal and run the command node v. This command prompts Node.js to return the current version number installed on your machine. It's essential to see a version number that is greater than 18, as this ensures compatibility with the latest features and functionalities required for managing packages and running development servers. This step is crucial before proceeding further, as a compatible Node.js version lays the groundwork for building and deploying your Vue.js applications smoothly. Once you see the version number displayed, you'll know that you're all set to continue your journey into the world of Vue.js development. Next, we will write the command to create our first Vue application using the Vue CLI. By running npm init Vue at latest, we initiate the process to scaffold a new project. This command allows us to quickly set up our development environment while guiding us through a series of prompts. You'll be asked for basic project details like the project name and optional features, such as TypeScript for static typing or EaseLint for maintaining code quality. Selecting the relevant options will help customize your project to fit your development needs. Once the project structure is in place, we need to ensure our application has all the necessary dependencies. This is done using the command npm install. This command goes through the package JSON file created during the project setup, fetching and installing all the libraries and tools required to run your Vue application efficiently. By completing these steps, you're laying a solid foundation for your application, enabling you to focus on building your features and components as you continue learning and working with Vue.js. Now let's start our local development server to see our Vue.js application in action. To do this, we will run the command npm run dev in our terminal. This command triggers a script defined in the package JSON file, which is automatically created when we initialized our Vue project. It sets up a development server that compiles our code and allows us to see real-time updates as we make changes. Once the server is running, you should see an output indicating where your application is accessible. typically at http://127.0.0.15173/. Opening this URL in your browser will reveal your very first Vue.js application, showcasing the basic structure that Vue provides. This immediate feedback is a powerful feature of the Vue development environment, allowing you to iterate quickly on your designs and functionality. Additionally, running this command also enables hot module replacement, meaning that when you save changes in your code, the browser automatically reflects those updates without needing a full-page refresh. This fluid development experience streamlines the process of building interactive applications, allowing you to focus more on coding and less on waiting. Now let's take a look at the structure of the app Vue file, which is central to our Vue.js application. This file demonstrates Vue's single-file component structure, featuring sections for template, script, and style, which help keep our code organized and maintainable. In the template section, we define the HTML structure, starting with a div that has an ID of app, which serves as the main container for our application. Within this div, we have an h1 element displaying a welcome message, setting the stage for user engagement. Next, we move to the script section, where we export an object that defines our component's configurations. Here, we set the name of the component to app. This is important for debugging and helps tools recognize this component. Finally, in the style section, we style the app to enhance its visual presentation. We apply a font family and center the text, ensuring that our application looks polished and appealing. This structured approach allows us to clearly separate our concerns, making it easier to manage and scale our Vue application as development progresses. Now let's take a look at how to implement reactivity in a Vue component using the Composition API. First, we define our template, where we display the current message in an h2 tag and provide a button that, when clicked, will invoke the change message function. This interaction is at the heart of creating a dynamic user experience. Next, we transition to the script section, where we import the ref function from Vue. The ref function is essential for creating a reactive reference to the message variable. This allows Vue to track changes to message's value. Initially, we set message to hello VUE.JS to provide a default state. Then we define the change message function, which updates the value of message when the button is clicked. When this function runs, Vue's reactivity system takes over, updating the displayed message on the DOM without manually manipulating it. Finally, we return both message and change message from the setup function, making them available for use in our template. This approach showcases the simplicity and elegance of Vue's reactive capabilities. Now let's implement a header component that will enhance our application's UI. We start with a single file component named header Vue, which is comprised of 3 distinct sections: the template, the script, and the style. In the template section, we define the HTML structure of our header, which includes an h1 element displaying the title of our application, My Vue Application. This encapsulates our header logic neatly within a reusable component. Next, in the script section, we use JavaScript to define the component's behavior. We export an object with the name header, which allows Vue to recognize and utilize this component throughout the application. This modular design not only promotes cleaner code, but also ensures that our header can be independently maintained or modified without affecting other parts of the app. Finally, the style section features scoped CSS, allowing us to style our header specifically without affecting other elements. Here, we set a background color, padding, and text color, which together create a consistent and appealing user interface. By implementing this component, we demonstrate how Vue's component-based architecture fosters better organization and reusability, making our code more manageable as our application scales. As we wrap up this introduction to Vue.js, you should now have a solid understanding of what Vue is, its benefits, how to set up your development environment, and how to build basic components. Vue's flexibility and simplicity make it an excellent choice for both small projects and large-scale applications. The more you dive in, the more you'll discover what Vue.js can do. If you're excited to learn more, remember that there are tons of resources, documentation, and a warm community waiting to help you on your Vue journey. Don't forget to subscribe for more tutorials, tips, and tricks on web development. Happy coding, and see you in the next video. Now let's see how we can verify that Node.js and npm are successfully installed on your machine. We'll do this by opening a terminal window and running 2 simple commands. The first one, node v, checks the version of Node. Vue.js installed, while the second command, npm-v, displays the version of npm, the package manager that comes with Node.js. These commands are essential as they confirm that the installation was successful, allowing us to utilize Node.js for our Vue.js development. If both commands return a version number, that's a clear indication that your development environment is set up correctly. This foundational step is key to ensuring we can further manage dependencies, install packages, and build our Vue applications effectively. Thus, running these commands not only serves as a verification process, but also introduces important tools we'll continually utilize in our development workflow. Next, we will install Vue CLI, which is essential for creating and managing Vue applications. To do this, we'll use the command to install Vue CLI globally on our machine, enabling us to access it from any terminal window. The G flag in the command signifies a global installation, which is important for convenience, as you won't have to navigate to a specific project folder to use it later. This installation process may take a few minutes, so be patient while it sets everything up in the background. Once the installation is complete, it's crucial to verify that Vue CLI is installed correctly. We can do this by running a simple command that checks and displays the current version of Vue CLI on your system. If a version number appears, it confirms that Vue CLI is successfully installed, effectively equipping you with a powerful tool to streamline the creation of your Vue.js projects. With this setup completed, you are now ready to move forward and create your first Vue application with ease. Now that you've set up your development environment and are ready to create your first Vue application, let's go through the steps of the commands you'll be using. First, we'll navigate to the desired directory where you want to store your projects. For this, you'll use the cd command followed by the path to your projects. By doing this, you ensure that all your future Vue applications are organized in a specific location. Next, we'll create a new Vue project using the Vue CLI, which greatly simplifies project initialization. You'll execute the command to create a project with your chosen name, which can be customized as you see fit. The Vue CLI will prompt you through a configuration process, guiding you to select default options suitable for beginners. Once the project structure is established and dependencies are installed, you can navigate into the newly created directory. Finally, to see your application in action, you'll run a command to start the development server. This compiles your code and serves it locally, allowing you to view your application in the browser. Following these steps lays the groundwork for building your interactive Vue application. Now let's take a look at a simple yet foundational component of our Vue application, app Vue. This file provides an organized structure that separates the different parts of our component, the template, script, and style sections. In the template section, we define the HTML structure of our application. Here, we've created a div with an ID of app, which contains a welcoming h1 header. This structure is essential as it serves as the visual foundation where we will build the user interface of our Vue app. Next, we move to the script section, which handles the application logic. In this example, we export the default component with a specified name, app. This is crucial for component identification and helps maintain the modular nature of our Vue application. Finally, the style section allows us to apply CSS styles directly within the component. We define the font family and text alignment, showcasing how easy it is to style our application in a maintainable way. By organizing our component this way, we enhance readability and streamline development. Now let's take a look at how we can set up our Vue application by writing the main.js file. This file serves as the entry point for our Vue app, where we will initialize Vue and mount our root component to the DOM. First, we import the createApp function from Vue. This function is essential as it allows us to create a new Vue application instance. Next, we also import the app component, which serves as the main component for our application. With these imports in place, we can now instantiate our Vue application using the createApp function, passing in the app component as an argument. This step is crucial as it tells Vue which component should serve as the root of our component tree. Finally, we call the mount method on this app instance, specifying the app element in our index.html file. This action connects our Vue application to the DOM, enabling Vue to take control of that element and render the app component into it. By maintaining this structure, we keep our app modular and set the foundation for future enhancements. Now that we have understood how to manage dependencies in our Vue application, let's see how we can install and use the Axios library for making HTTP requests. To start utilizing Axios, we will execute a command in the terminal to install it. This command not only downloads the Axios library, but also adds it to our project's dependencies listed in the package.json file. This file is essential as it keeps track of all libraries that our application requires to function properly. Next, we will write the code to import Axios into our Vue components. By doing this, we can leverage Axios' powerful features for handling API requests. The import statement links the Axios library to our component, allowing us to use its methods for fetching data from external sources or APIs. With Axios ready in our project, you can conveniently start fetching data, which will enhance your application's capabilities. This streamlined approach to package management and data requests is crucial in modern web development, showcasing how easily you can expand your application's functionality with just a few simple commands. Now let's see how we can implement version control in our project using Git. First, we want to verify that Git is installed on our system by typing git version in the terminal. This command will display the current version of Git, confirming its installation. If you don't see a version number, it's essential to install Git from git-scm.com for proper functionality. Next, we will initiate a Git repository in our project directory. By executing git init, we create a new repository which allows us to start tracking changes made to our files. This sets the foundation for managing our project's version history effectively. After modifying files in our project, it's time to stage those changes for commit. We do this using the command git add, which adds all modified files to our staging area, preparing them for the next commit. This step is crucial as it allows us to control which changes we want to include in our project's history. Finally, we will commit our changes using git commit m initial commit. This command captures a snapshot of our current project state and adds a message, noting the purpose of this change. Maintaining regular commits ensures a detailed history of our project development, allowing us to easily track and, if necessary, revert changes in the future. As we wrap up setting up your development environment, you now have a complete understanding of how to install the necessary tools, create a Vue project, navigate its structure, and utilize npm for package management. We also took a moment to touch on the importance of version control with Git. With these foundational concepts laid out, you are fully equipped to begin your journey with VUE.JS. There's a whole world of possibilities waiting ahead with interactive applications and beautiful user interfaces just a few lines of code away. So dive in and start building. Happy coding! Let's put our acquired tools and knowledge to the test by creating our very first VUE.JS application, shall we? So far we covered the essential setup for the VUE.JS development environment, which included installing Node.js and Vue CLI, understanding the structure of a Vue application, the functionalities of npm for managing packages, and even the importance of version control with Git. Today, we will dive into the practical approach of building our first VUE.JS app, where we'll implement everything we learned and craft a functional, interactive application. Now let's take a look at how we can create our Vue application. To kickstart our project, we will use the Vue CLI command Vue create my first Vue app. This command initializes a new Vue project with the specified name. As we execute it, the Vue CLI prompts us to select features we want for our application. For newcomers, it's advisable to stick with the default preset, which sets us up with Vue 3 and sensible defaults. Next, we navigate into the project directory using cd my first Vue app, which allows us to access the application's structure and files. To see our app in action, we will start a local development server with the command npm run serve. This command compiles and serves our application, making it available for preview in a web browser, typically at http://localhost 8080/. It's a straightforward process, but it's essential as it lets us view live changes as we develop the app. This foundational setup is crucial, as it enables us to build, test, and iteratively refine our Vue application as we move forward. Now let's implement the commands to navigate into our app directory and start the development server. First, as we move into the newly created project folder, we use the command cd my first Vue app. This command changes the current working directory to your newly established Vue project, allowing us to execute commands within this specific context. Once we're inside the project directory, we need to start our app locally, which we achieve by running npm run serve. This command triggers the development server, providing us with a local setup where we can view our application in a web browser and see changes in real time as we develop. If everything runs smoothly, your terminal will display a message showing that the application is live at http://localhost 8080/, empowering you to make quick iterations and test your features continuously. This step is crucial as it sets the stage for interactive development, enabling an efficient workflow as you begin crafting your first VUE.JS application. Now let's take a look at how we can implement a simple counter in our Vue application. In the template section, we start by creating a basic structure containing a heading and a display for our count, dynamically bound using Vue's interpolation syntax, count. This means that whenever we update the count value in our script, the displayed number will automatically change to reflect that. Next, we introduce buttons for incrementing and decrementing the count. Each button uses the @click directive to bind its click events to methods defined in our script section. We create two methods, increment and decrement, which simply adjust the count variable by adding or subtracting 1, respectively. Additionally, we want our users to see a visual indication of the count state, so we conditionally apply classes to the heading based on the value of count. If the count is below 0, it will display in red. If 0 or more, it will be green. This dynamic styling enhances the user experience, providing immediate visual feedback on their actions. Finally, we implement a new method called reset that sets the count back to 0, along with an accompanying button, making our app more functional and user-friendly. Now let's implement a simple counter functionality in our Vue application. First, we define a template structure that includes a header, a display for the current count, and two buttons for incrementing and decrementing the counter. The current count is dynamically displayed using double curly braces, which is a core feature of Vue's data binding. Next, within the script section, we set up our component's logic. We introduce a new data property called count, which is initialized to 0. This property will be the backbone of our counter feature. In the methods section, we create two functions, increment and decrement. The increment method increases the count by 1 while the decrement method decreases it. These methods are linked to the buttons using the @click directive, ensuring that each button triggers the appropriate function when clicked. Finally, our styles are defined to give a clean look to the app and maintain a fluid user interface. With this setup, users can interact with the app and the counter will update in real time, showcasing the reactive nature of VUE.JS. Now let's see how we can enhance the interactivity of our Vue application by applying dynamic styles based on the counter's value. We'll begin by modifying our template section to include a dynamic class binding for the header displaying the current count. By using the class directive, we can conditionally apply styles that change the text color based on whether the count is below 0 or above 0. If the count is negative, the class red will be applied, making the text red, while the class green will apply when the count is 0 or positive, changing the text color to green. Next, in our style section, we will define these classes to control the visual representation of the count. The red class will set the text color to red, while the green class will set it to green, providing immediate visual feedback to the user regarding the current count. This interactive styling not only enhances the user experience but also emphasizes the responsive nature of our Vue app, making it more engaging and visually informative. After implementing these changes, remember to save your file and refresh your browser to observe how the count's color reacts dynamically as the user interacts with the application. Next, we will implement the reset functionality to enhance our counter application. To do this, we will add a new method called reset to the methods section of our component. This method will simply set the count back to 0, allowing users to quickly restart their counting experience. It's an integral feature, as it provides users with a way to clear the current count without requiring them to refresh the page. Now, let's see how we can include a button for this functionality. By adding a reset button in the templates section, which invokes our newly created reset method on click, we ensure users can interactively set the count back to 0. Incorporating this button not only adds functionality, but also improves the user experience by making it clear that resetting the counter is a straightforward action. After implementing these changes, the complete code integrates all functions effectively, incrementing, decrementing, and resetting the counter, all designed to work together seamlessly. Now save your changes and check your application to see the three buttons, increment, decrement, and reset, working in harmony. Now we've built a simple yet functional counter application. As we wrap up this segment, let's take a moment to reflect on how much we've accomplished. From setting up our development environment to creating interactive components, you've designed a small app that not only demonstrates basic functionality but also highlights the reactive nature of VUE.JS. Remember, the beauty of VUE.JS lies in its simplicity and flexibility, enabling you to create powerful applications with ease. As you continue your learning journey, consider expanding this counter app. You might add features like saving the count to local storage or even implementing different counting strategies. The possibilities are vast. Now let's prepare our Vue application for deployment by optimizing it for production. To do this, we will run the command npm run build. This command triggers the build process in Vue CLI, which compiles and minifies our application's files, ensuring they are as lightweight and efficient as possible for the web. After executing this command, Vue CLI will generate a dist directory. This directory will contain all the final, production-ready files that are essential for deploying our application. This includes optimized JavaScript, CSS, and HTML files that ensure faster load times and better performance for users. Once the build is complete, you will need to take the contents of the dist folder and upload them to a web server or use a hosting service like Netlify or Versal. These steps will make your application accessible to users around the world. This knowledge not only equips you with deployment skills, but enhances your understanding of the development workflow in Vue.js. To wrap up, we've taken significant strides in understanding Vue.js and building our first app. Together, we've learned about the app structure, dynamic data binding, and how to create interactivity through methods and events. We also explored styling dynamic classes and prepared our app for deployment. I encourage you to dive deeper, experiment with new features, and challenge yourself to build more complex applications. Each step you take will solidify your understanding and expertise in Vue.js. Happy coding, and I look forward to seeing the amazing applications you will create. As we dive into the realms of web development, one exciting tool you might want to consider is VUE.js, a progressive framework that makes building user interfaces a breeze. Today we're going to take a closer look at how to harness Vue.js capabilities by creating a simple to-do list app. This app will not only help us understand Vue.js better but also introduce key concepts such as reactivity, component-based architecture, and more. So far, we learned the essential setup for a Vue.js environment and created our first application, My First Vue App. We implemented a functional counter feature, allowing users to increment, decrement, and reset the count with dynamic styling based on the count's value. Additionally, we prepared our app for deployment by building it for production. As we continue to explore Vue.js, we're encouraged to expand our application's features and deepen our understanding of its capabilities. Now let's talk about how we can create a functional and interactive to-do list application using Vue.js. Now let's implement the setup for our Vue project. First, we initiate our project using npm init vue at latest, which prompts us through some basic configuration such as choosing a project name and preset options. After navigating into our project directory, we proceed to clean up the default files in the components folder, focusing on crafting our application from scratch, initiating this process in the app view file. Next, we set up a blank template in the app view, ensuring we have a clean slate to add our components. This structure consists of a script tag for our TypeScript setup, an empty template for our HTML and scoped styles, promoting modularity and preventing style leakage. Now let's see how to create the header for our to-do app by defining the app header view component. This component, including a title and a brief description, will enhance our application's user interface. We will style it to ensure it stands out while keeping our styles organized within scoped styles to prevent any overlap with other components. As we advance, we'll introduce our core functionality through components like to-do list, view, and list item view, ensuring our application not only looks good but also functions effectively, providing a dynamic user experience. Next, we will write the app header view component, which serves as the title for our to-do list application. This component features a template that includes a header element with a main title and a descriptive paragraph beneath it. The use of a scoped style ensures that the styles defined here apply only to this component, preventing any style conflicts with other parts of the application. Now let's see how we can add this header component to our main application by modifying the app view file. We will import the app header component at the beginning of the script section, enabling us to leverage it within our template. The goal is to embed the header above the main content of our app, establishing a clean structure for our interface. After saving your changes and running the development server, the header should appear on the page, welcoming users to the to-do list application. With the header in place and visually appealing, we can now move on to creating our main feature, the to-do list itself, expanding the functionality and interactivity of our application. Next, we will create a new component called To-Do List, VUE, which will manage our task list. In this component, we begin by importing necessary functionality from VUE, including ref and computed, to help us create reactive data properties. We define an item type that consists of a title and an optional checked property, which allows us to represent each task accurately. Now let's implement a list items array containing a few sample tasks. Some are marked as completed while others are not. This array will serve as our primary data source. To ensure tasks are displayed correctly, we utilize a computed property called sortedList, which sorts the tasks, first showing those that are unchecked followed by the checked ones. In the template section of the component, we create an unordered list where each task is rendered using a listItem component. We loop through our sorted list and bind the isChecked prop to pass the status of each task, allowing us to dynamically reflect their completion status on the UI. This structure facilitates a clear organization of the tasks and ensures they update in real time as their states change. Now let's implement the listItem component, which serves as a visual representation of each task in our to-do list. We start by utilizing VUE's defineProps to accept the isChecked property. This allows the component to dynamically indicate whether a task is completed or not. Next, we create a template where we use a label element that binds a class based on the isChecked value. When a task is marked as complete, it will apply the class checked, giving a strike-through effect to visually signify completion. Inside the label, we include an input checkbox that's also bound to the isChecked property, ensuring that it reflects the current state of the task. Now, as the component is styled, the scoped CSS ensures that any styles specifically for the checked class, which adds a line-through decoration, are applied only within this component, maintaining encapsulation. This structure not only enhances the readability of tasks, but also adheres to Vue's reactive principles, making sure the user interface updates seamlessly when a task status changes. Now let's implement the final integration of the to-do list component into our main application. First, we'll import to-do list alongside app header within the script setup section of app VUE. This allows us to utilize these components together, enriching our app structure. In the template section, we'll replace the empty template with both app header / and to-do list, thus presenting the header and the to-do list on the main page. This layout not only adds coherence to our application but also establishes a clear separation of concerns, as each component handles a specific part of the UI. With this integration, when you start the development server again, you'll observe that the header appears atop the to-do list, marking successful modularization of your code. Next, to add interactivity to the to-do list, we can enhance the toggleItem function. This method will allow users to check off tasks by clicking on them, thereby updating the item's state within the listItems array. By directly changing the checked property of each item, we ensure that our application's reactivity works seamlessly, providing immediate visual feedback to the user without needing to refresh the page. This is a crucial feature as it enhances user experience by making the app feel responsive and interactive. Now let's implement the functionality that allows users to toggle the completion status of tasks in our to-do list. We start by defining a method called toggleItem. This method accepts an item as a parameter and uses it to invert the checked property. When a user clicks on a task, this method will be triggered, effectively marking it as completed or uncompleted, which gives a dynamic interaction to our app. Next, we will update how we use the listItem component in the template section. It's essential to include a click event listener using @clickPrevent, which prevents the default action and instead calls the toggleItem method when a user interacts with the list item. This allows the application to respond to user actions in real time, reflecting changes immediately on the screen without needing a page refresh. By making these adjustments, we are enhancing the to-do list's interactivity, ensuring that the user experience is smooth and engaging as they manage their tasks more efficiently. It's important to test the functionality to confirm that items update visually and maintain reactivity. Now let's implement the functionality to ensure our to-do list items persist even after a page refresh. We will create two helper methods, setToStorage and getFromStorage. The set-to-storage function will take our current list of items and save it to the browser's local storage under the key list items, converting the list into a JSON string for storage. This enables seamless saving of the current state of the to-do items. Next, we'll implement the getFromStorage method, which retrieves the list of items from local storage. It checks if any items are stored. If so, it passes the JSON back into a JavaScript object, ensuring that our application can access it when loaded. This is vital for maintaining the user's input and progress. To tie these functionalities into Vue's lifecycle, we will utilize the onMounted lifecycle hook. By calling getFromStorage in this hook, we ensure that when the to-do list component mounts, any stored items will be pulled from local storage and added to our existing list, allowing users to see their tasks immediately upon accessing the app. This approach enhances user experience by providing continuity between sessions. Now let's implement a method that allows users to toggle the completion status of their tasks. The toggleItem function takes an item as a parameter and changes its checked state by negating its current value. This means if the task was previously marked as completed, it will now be marked as incomplete, and vice versa. Next, we need to ensure that our application's state reflects these changes even after a page refresh. To do this, we need to call the setToStorage function within the toggleItem. This function takes the current list of items and saves it to the browser's local storage, ensuring that any updates to the task list are persistently recorded. By executing this within the toggleItem, we not only modify the task state in the UI but also keep the modifications consistent in local storage. With this setup, every change a user makes to their tasks will be captured, providing a seamless experience as they navigate between sessions, illustrating how effective state management can enhance your application. This will significantly elevate the functionality of our to-do list app, maintaining user continuity and data integrity. By now, you should have a fully functional to-do list app. What have we learned today? We've established a VUE.JS project, created components for our application's UI, implemented reactivity, and lastly, utilized local storage to ensure data persistence. This exercise not only demonstrates the effectiveness of VUE.JS but also highlights how component-based architectures simplify web applications. As you move forward, feel free to extend this project further, perhaps by adding features such as item removal, editing tasks, or integrating external APIs. Learning is all about experimentation, and with VUE.JS you have a powerful toolkit at your disposal. Until next time, happy coding! Building a web application is an exciting journey, and today we'll focus on taking our to-do list app to the next level. So far, we learned the fundamental setup for a VUE.JS environment and created our first application, including a functional to-do list app. We developed components like AppHeader, to-do list, and list item, while implementing reactivity and local storage to manage tasks persistently. Additionally, we established methods to toggle task completion and save updates to local storage, ensuring data continuity. This project showcases the power of VUE.JS and its component-based architecture in building interactive web applications. Now we will dive deeper into enhancing our application by adding new features, tweaking existing functionalities, and exploring best practices to ensure our app is both efficient and user-friendly. Now let's take a look at how we can set up the Add To-Do item component to allow users to add tasks to their to-do list. In this component, we utilize Vue's composition API and the ref method to create a reactive property, new task, which stores the input from the user. In the template section, an input field is bound to new task using vModel, enabling two-way data binding. This means that whenever the user types in the input field, new task automatically updates to reflect those changes. Alongside the input, there's a button that triggers the Add Task method when clicked. Inside the Add Task method, we first check if new task is not empty to prevent the addition of blank tasks. If a valid task is present, we would emit this new task to the parent component for further processing. Regardless of whether task is added successfully, we reset the input field back to an empty string, preparing it for the next input. This straightforward approach allows users to manage their tasks efficiently and enhances their experience with the to-do list app. Next, we'll implement the Add To-Do item component into our to-do list Vue file. We begin by importing Add To-Do item and initializing a reactive list items variable which will store our tasks. This ensures that any changes made to the list automatically update the UI. Now we'll enhance the template section to include our Add To-Do item component, where we utilize the add task event listener to listen for new tasks emitted from the child component. When a new task is added, it triggers the handleAddTask method we've defined in the script section. Let's examine the handleAddTask function. This method takes the newly added task as a string, pushes it onto the listItems array, and marks it as unchecked by default. It's important that we also call setToStorage to save our updated task list to local storage, ensuring persistence across sessions. Through these implementations, we not only dynamically manage task entries but also maintain data integrity, enhancing the overall functionality of our to-do list app. These additions facilitate an improved user experience, empowering users to actively manage their tasks. Now let's extend the functionality of the listItem component by adding a delete button. In the template section, we create a button labeled delete next to the checkbox and task title, binding it to a click event that calls the removeTask method. This button enhances user interaction by allowing them to remove tasks directly from the list. Next, we need to implement the logic behind the removeTask method, which we define in the script section. Here we utilize the defineEmits function to declare an event named remove. When the delete button is clicked, the removeTask method emits this event, signaling the parent component that a task should be removed. This setup is crucial for maintaining a clear architecture in our Vue application, allowing for efficient communication between components. Following this, we'll handle the task removal in the parent component to-do list Vue, where we listen for the remove event emitted by listItem. In response, we will define a method that identifies which task to remove from the list based on its index. This process not only keeps our task list updated, but also ensures that we persist changes by updating local storage. Now let's take a look at how we can implement the task removal feature in our to-do list Vue. We begin by integrating an event listener in the template. This listener, which listens for the remove event emitted by each listItem, is crucial for capturing the user's intent to delete a specific task. We achieve this by binding the @remove event to our handleRemoveTask method, passing the index of the item to be removed. Next, we will define this handleRemoveTask method in the script section. This method is designed to modify the listItems array by utilizing the splice method, which effectively removes the specified item from the array based on its index. After removing the task, it's essential to ensure data persistence, so we call setToStorage, which updates the local storage to reflect the current state of our task list. This approach guarantees that any modifications made to the task list are saved, thereby enhancing the reliability and usability of our to-do list application. By implementing these features, we empower users to manage their tasks effectively, contributing significantly to the overall functionality of the application. Now let's implement the filter options component to enhance our to-do list app's functionality. In this component, we create a simple user interface consisting of 3 buttons that allow users to filter tasks based on their completion status. Each button is linked to a click event that triggers the filterTasks method with a specific criteria: all, active, or completed. This approach ensures that users can easily switch between views of their tasks. Within the script, we utilize the defineEmits function from Vue to create a mechanism for emitting events. When a user clicks one of the filter buttons, the component emits a filter-changed event along with the respective criteria. This event communication enables the parent component to adjust the displayed task list accordingly. The filtering logic will be handled in the parent component, where we will update the view based on the user's selection. Next, we will see how to integrate this filter functionality into the to-do list Vue component, enhancing our application's user experience by allowing users to focus on specific tasks while managing their lists effectively. Now let's integrate the filter options component into our to-do list Vue. First, we will start by importing filter options Vue at the beginning of our script. This allows us to use the filtering functionality we defined in the component. In the template section, we will render the filter options component above our task list, just as we did with the add to-do item component. Additionally, we will set up an event listener. When the user makes a selection in the filter options, the handleFilterChange method will be triggered, allowing us to respond accordingly. Next, we need to implement the filter logic in the script section. We'll create a reactive variable, currentFilter, initialized to all, which will track the current filtering criteria selected by the user. Following this, we will define a computed property named filteredItems. This property dynamically evaluates the tasks based on the value of currentFilter. For instance, if the filter is set to active, only tasks that are not completed will be shown. In contrast, if completed is chosen, it will display only those tasks marked as completed. If all is selected, all tasks will be returned. Lastly, the handle filter change method will update current filter, ensuring that our task display is always aligned with the user's preferences. At this point, we've covered a lot of ground. We have explored adding tasks, deleting tasks, and implementing filter options. Each of these features adds a layer of functionality, making our app much more user-centric. As we finalize the enhancements to our to-do list app, it's crucial to take a moment to reflect on optimizing our app's performance and maintainability. One best practice in Vue.js, especially as we build out larger applications, is to take advantage of Vue Router for managing different views effortlessly. Let's consider this option for future iterations of our app. Implementing Vue Router would allow users to navigate between different pages, such as a detailed task view or a settings page. While we won't dive deep into that today, it's an exciting prospect for expanding the capabilities of our application. In conclusion, building up our to-do list app has shown us how taking a component-based approach with Vue.js can create an engaging web application. We tackled tasks comprehensively, from adding and managing tasks to filtering and improving usability. Jaw-dropping, right? Creating an application from scratch can indeed be very fulfilling. Don't forget, the learning doesn't stop here. Explore extending your app further, maybe integrate an API for live data fetching or try implementing user authentication. The sky's the limit. Keep coding, keep experimenting, and most importantly, have fun. Until next time, stay curious and keep building those amazing apps. The Vue.js DevTools is an essential tool for developers working with Vue.js applications, as it simplifies the debugging process and enhances the overall development experience. In this discussion, we're diving deep into how to utilize Vue DevTools effectively to monitor and debug our applications. So far, we learned that we developed a functional to-do list app using Vue.js, including features like task addition, deletion, and filtering. We created components such as add to-do item, which allows users to input new tasks and filter options, enabling them to view tasks based on their completion status. Additionally, we ensured data persistence through local storage and explored best practices for future enhancements, including the potential integration of Vue Router. Overall, we have built a user-centric application showcasing the power of Vue.js and its component-based architecture. Now we will talk about how to leverage Vue DevTools for debugging and enhancing the performance of our applications. Having a robust set of tools at your disposal can make a world of difference when it comes to debugging. Vue DevTools is a browser extension that enables you to inspect your Vue components and observe the state in real time. This can be particularly useful when you're faced with a tricky bug or trying to optimize your application performance. The first step is to install the Vue DevTools extension. You can find it in the Chrome Web Store or the Firefox add-ons site. Once installed, you'll see a new Vue tab in your browser's developer tools, which we'll explore in detail. Next, we will write the following code that defines the data structure for our to-do list component. The data function returns an object that contains a single property, list items. This property is an array which will hold the tasks for our to-do list. Each task is represented as an object within this array with two attributes, title and checked. The title is a string that represents the name of the task, while checked is a boolean that indicates whether the task has been completed or not. In our example, we have two tasks. Task 1, which has not been completed, checked is false, and Task 2, which is marked as complete, checked is true. This structure allows us to dynamically manage and render tasks in our application, enabling features such as toggling the completion status or filtering the list based on these attributes. By utilizing Vue's reactivity system, any changes made to list items will automatically reflect in the user interface, providing a seamless experience as users interact with the to-do list. This setup forms the foundation for the functionalities we will implement next. Debugging is often about isolating components and understanding how they interact with one another. Vue DevTools facilitates this by providing a clear tree structure of your components. For instance, if you have components like add to-do item or filter options, they will be nested under to-do list. You can click on each component to reveal its state, props, and context. Let's say you want to debug the updating mechanism for tasks in our add to-do item. By selecting Add to-do item within the Vue DevTools, you gain access to its props and watch how it interacts with the parent component. If props are not propagating correctly, you can intervene in real time by updating them in the DevTools to immediately see the effect on the UI. This rapid iteration speeds up the feedback loop significantly. Furthermore, Vue DevTools allows you to track events emitted from components. The event tracking feature helps determine whether certain actions like adding a task are triggering any unwanted behaviors. When an event is emitted, you can inspect the payload and confirm that it's what you expect it to be. When debugging any JavaScript application, performance should also be a concern. VUE.JS provides a performance tab to help you measure your app's efficiency. It offers insights into how long Vue takes to render components and respond to changes in data. This feature is particularly useful when dealing with a component that seems sluggish or has visible delay issues. Consider a situation where you've added numerous tasks into your to-do list and rendering begins to slow down. By using the performance profiling feature, you can see which components take longer to render. Here, emphasis should be placed on utilizing efficient reactivity patterns and ensuring minimal computations in your render function. Here's how you might approach performance optimization based on what you observe in your Vue DevTools. 1. Identify problematic components via the Performance tab. 2. Refactor unnecessary complexity from render functions. 3. Utilize VIF instead of vShow when displaying elements conditionally, as it improves reactivity. Now let's take a look at how we can implement state management in our to-do application using Vuex. We start by creating a new Vuex store, which serves as a centralized repository for managing the state of our application. The store's initial state defines a tasks array that will hold our list of tasks. To modify this state, we define mutations, which are synchronous functions that update the state based on the provided payload. In this case, we have two mutations, addTask to add a new task to the array and removeTask to remove a task by its index. Next, we implement actions, which are functions that can contain asynchronous operations and can call mutations. The addTask action commits the addTask mutation to update the state with a new task, while the removeTask action triggers the removeTask mutation to delete a specified task. By utilizing this structure, we can effectively manage our application's state and ensure that the UI remains in sync with the data changes, enhancing the overall user experience in our to-do application. As we continue exploring Vue DevTools, it's essential to mention how enhancing your productivity with shortcuts can streamline your workflow. For instance, use the key combination Ctrl+Shift+I in Chrome to invoke the developer tools, making it seamless to toggle between inspecting elements and tracking Vue-related state without losing context. Additionally, Vue DevTools allows for hot reloading of components in development mode. This means you can make changes to your Vue files and see the updates in your browser without needing to refresh, significantly speeding up the debugging process. This feature is vital for iterative development where you might quickly change component data, update styles, or adjust event handlers. No need for repetitive refreshes, your changes apply in real time. Now, while we have discussed a variety of practical tools and techniques within Vue DevTools for enhancing your Vue.js application structure, it's essential to cultivate best practices for leveraging these features. First and foremost, maintain clear naming conventions for components and state properties to make navigation intuitive in the Vue DevTools. This enhances readability when inspecting your app. Also, consider integrating formal documentation in your project that captures how components are supposed to behave and interact. This clarity will aid you and any collaborators when using Vue DevTools to debug or extend features in the future. Furthermore, regularly evaluate your component hierarchy in Vue DevTools. Ensuring a logical and maintainable component structure not only helps in debugging, but also in onboarding new developers to your project who will similarly use these tools. Vue DevTools is a powerful ally for any Vue developer, transforming the potentially tedious task of debugging into a quick and insightful experience. With the combination of state inspection, performance metrics, time travel debugging, and hot reloading, it offers everything needed to not only enhance existing Vue applications, but also accelerate the overall development process. In conclusion, give yourself the advantage of mastering Vue DevTools. Experiment with its features, dive into component states, and break down complex applications into manageable sections. This confidence in utilizing your tools will undoubtedly streamline your development journey, leading to cleaner code and a more robust application. Keep building, experimenting, and learning. Your journey in the Vue ecosystem is only just beginning. Now that we can build a small app, we can add a bit more complexity. In this lesson, we will delve into enhancing our application by integrating external APIs, managing asynchronous data, applying styling frameworks, and implementing unit tests. It's going to be an exciting journey where we'll make our app not only more functional but also visually appealing and robust. So far, we learned that VUE.JS DevTools is crucial for debugging and improving the development experience of VUE.JS applications. We developed a functional to-do list app with features for task management and explored strategies for utilizing Vue DevTools to inspect components and optimize performance. We discussed various debugging techniques, including time travel debugging and performance profiling, while emphasizing the importance of best practices in component structure and naming conventions. Overall, mastering Vue DevTools equips developers to handle complexities in their applications more effectively. Now we will cover how to connect our applications with external APIs and give them real-time data to work with. Now let's implement our Vue.js application using the Vue CLI. To start, we can run the command npm init vue at latest, which sets up a new Vue project. This command prompts you for a project name and necessary configurations, creating a structured environment for our application. After this setup, we can navigate to our project directory and install any required dependencies. Next, we will integrate Tailwind CSS, a utility-first CSS framework that simplifies styling our application. We can install it along with PostCSS and AutoPrefixer using the command npm install dtailwinds post-AutoPrefixer. Following the installation, we need to initialize Tailwind CSS with npx tailwinds init p, which creates a configuration file for customizing our style generation. This configuration file is crucial for setting up which files Tailwind will analyze for class names, ensuring that unused styles are purged in production. Now let's create a CSS file in the src directory to import Tailwind's base, components, and utilities. Finally, we will include this CSS file in the main application file, effectively linking our styling framework to our Vue components, enabling us to create responsive and visually appealing designs throughout our weather app. Next, we will install Tailwind CSS, which is essential for styling our Vue application efficiently. To do this, open your terminal and execute the command that installs both Tailwind CSS and PostCSS, along with AutoPrefixer, tools that help process your styles effectively. After installing these packages, we need to initialize Tailwind CSS. By running the initialization command, a configuration file will be generated, where we can specify which files Tailwind should examine for class names. It's crucial that you correctly set the content property in your Tailwind config.js file to enable Tailwind to purge any unused styles during production, helping to keep our final CSS lightweight. Now let's create a new CSS file within the src directory. In this file, we will import Tailwind's base styles, components, and utilities, which will establish a foundation for our styling. The last step in this setup involves importing the CSS file into our main application file, typically located in src/main ts. This incorporation ensures that Tailwind styles are applied throughout our app. With these steps completed, we are ready to build our weather component, enhancing the user interface further as we move forward. Now let's take a look at defining our Vue component weather report view. Within this component, we utilize TypeScript to create types that describe the data structure we expect to receive from the weather API. This includes the weather data type, which encapsulates details such as location, temperature readings in Celsius and Fahrenheit, precipitation information, wind conditions, and descriptive text about the current weather. Next, we define a coords type for the coordinates needed to fetch weather data. Following that, we create a props interface to type our component's props, allowing us to pass in coordinates in an expected format. We then initialize a reactive data reference named data, which will hold our weather data once it is fetched. Now let's implement a fetching function named fetchWeather. This asynchronous function constructs a request URL using the provided coordinates to get live weather information. It employs the built-in fetch API to retrieve data from the weather service. We make sure to use an environment variable for the API key to keep it secure. This function not only fetches the data, but also returns it in a structured format for use within our component. Next, we will implement the onMounted lifecycle hook to trigger data retrieval when our component mounts. By using this hook, we ensure that the fetchWeather function is invoked as soon as the component is placed in the DOM, initiating the process of fetching live weather data based on the coordinates passed in through props. This setup is essential for capturing real-time updates as our weather app loads. Now let's take a look at the template structure that facilitates the display of the fetched data. We'll create an article element that renders only when the data object is available, showcasing the weather specifics like temperature, location, and wind speed. This conditional rendering is a powerful feature of Vue, VUE.JS that enhances user experience by providing immediate feedback. Below this, we include a loading message that appears while the data is being retrieved, maintaining clarity for the users during the wait. Utilizing this approach not only organizes our code but also optimizes the component's reactivity, ensuring interactive and engaging user interfaces. Next, let's take a look at how we can enhance the visual appeal of our weather report component by utilizing Tailwind CSS utility classes. In the provided markup, we create a template that centers the content and adds padding for better spacing. The article element uses Tailwind classes to apply a light gray background, padding, rounded corners, and a shadow effect, effectively transforming the weather report into an attractive card layout. The heading is styled with larger font size and bold weight, ensuring that the location's name and region stand out prominently. Each piece of weather information, including temperature, condition, and wind speed, is formatted with appropriate text sizes, allowing for clear readability. Importantly, we leverage utility classes in a manner that promotes easy adjustments, eliminating the need for an external CSS file. By doing so, we not only make the component visually appealing but also maintain responsive design principles. This streamlined approach simplifies future modifications to the layout as requirements evolve, facilitating a more efficient development process. Next, we will write a unit test for our weather report component to ensure it functions correctly. We start by importing the necessary shallow mount method from Vue test utils and the weather report component itself. Then, we encapsulate our tests within a describe block specifically for testing the weather report. Now let's implement a test case using the it function, which will check if the component renders without crashing. Inside this test, we use shallow mount to create a wrapper for the component, providing it with sample props for coordinates, specifically latitude and longitude set to 0. This allows us to check if our component can exist in the DOM without any issues. Finally, we include an expectation that asserts the wrapper indeed exists, confirming the component has rendered successfully. This basic test structure is essential for verifying that our component initializes properly, serving as a foundation for more complex tests that we will add later to ensure the functionality is robust and bug-free. Next, we will write a test to ensure that our component displays a loading message while waiting for data to be fetched. In this test, we use the shallow mount function from the Vue test utils library to create a wrapper of our weather report component, providing it with props for coordinates. The goal is to check if the text content of the rendered component includes the phrase loading when the data is initially undefined. This is crucial for enhancing user experience, as it informs users that their request is being processed. Now let's implement a mock for the fetch function to simulate the API response that our component will receive. This mocking is done using JS mocking capabilities, allowing us to define a resolved promise that mimics the structure of the expected API response. We create a response that includes location details and current weather conditions, thus enabling us to test how the component manages real data when it's available. This is essential for writing comprehensive tests, ensuring that our component behaves correctly under different scenarios, such as loading and displaying fetched data accurately. Next, we will implement our test cases using Vitis to ensure our weather report component functions as expected. We begin by creating a new file named weather report spec.ts. In this file, we set up a test suite for our component, starting with a simple test to verify that the component renders correctly without crashing when valid props for the coordinates are provided. Now let's write a test to check how our component behaves while it is loading data. We can do this by asserting that the loading message, loading, appears when the data property is initially undefined. This ensures users receive feedback that their request is being processed. Next, we will also mock the fetch function to simulate responses from our weather API. This approach enables us to control the data for our tests without relying on actual API calls. Finally, we will examine how our component displays the fetched weather data once the API responds. By writing tests that check both the loading state and the successfully retrieved data, we ensure that our application provides a reliable user experience. After implementing all tests, we will run them using the command npm run test, which executes our complete test suite and provides valuable feedback on our code's robustness. Next, we will write the function fetchWeatherData, which is responsible for retrieving weather information based on a specified city. This function is defined as an asynchronous arrow function, allowing us to handle operations that take time like making network requests. Inside the function, we first declare a variable API key, which you'll need to replace with your actual API key for the weather service. Now let's see how we can make an HTTP GET request using the fetch method. This method sends a request to the OpenWeatherMap API with the city name and the API key included in the URL. The response from the API is then awaited, meaning that our code will pause until the data is received. Once we get the response, we convert it to a JSON object. This is crucial because the data we need is formatted in JSON. Finally, the function returns this paused data, completing the process of fetching weather information. This encapsulation of functionality makes it easy to call this function with different city names throughout our application, providing a dynamic way to retrieve relevant weather data. Now let's see how we can display the weather data we've fetched in a user-friendly manner. We'll implement an asynchronous function called displayWeather that takes a city name as an argument. Inside this function, we use a try-catch block to handle potential errors during the API call, which is vital since API requests can fail for various reasons, such as network issues or invalid input. We begin by awaiting the result from our previously defined fetchWeatherData function, which retrieves the weather data for the specified city. Once we successfully receive the data, we log the current temperature and weather conditions to the console. This step is foundational. While logging is useful for debugging and initial testing, in a real application you would typically update the document object model DOM to display this information directly on the web page. Finally, we call the displayWeather function, passing in London as an example. This showcases how to initiate the process, and students can easily modify the city input to fetch weather data for any location. This combination of asynchronous handling, error management, and DOM interaction sets the groundwork for building responsive applications that effectively communicate real-time data to users. Now let's implement the user interface elements needed for our weather application. Here, we create an input field where users can enter a city name, alongside a button that fetches the weather information when clicked. The input field is defined with a placeholder to guide the user on what to enter, enhancing usability. Upon clicking the button, the application will display the relevant weather data. Next, we will set up an event listener on the button using JavaScript. This listener waits for the button click, at which point it retrieves the city name from the input field. Using the value obtained, we asynchronously call the displayWeather function, which is responsible for fetching and displaying the weather data for the specified city. This structured approach not only fosters a more interactive experience for users, but also efficiently manages their input, tying the UI back to the backend functionality we established earlier with API calls. In summary, this setup effectively bridges our front-end user interaction with the dynamic data retrieval from the Weather API. Now let's see how we can implement a simple Vue component for fetching and displaying weather data. The component starts with a template structure where we have an input field bound to the city data property using Vue's vModel directive. This directive enables two-way data binding, meaning as the user types into the input field, the city variable updates in real time. Below the input, there's a button that triggers the fetchWeather method when clicked. In the script section, we define the component's data function, which initializes three properties: city, weather data, and error. This setup is crucial for managing user input, fetched data, and any errors that may arise during the API call. The fetchWeather method is an asynchronous function that constructs a fetch request to OpenWeatherMap's API using the input city name. It includes error handling by checking the response. If the API does not return a successful status, an error message is set, making the user experience seamless. In case of successful data retrieval, the temperature and weather condition are displayed dynamically, while any encountered errors are shown directly in the component, empowering users with valuable feedback. Now let's implement the following Vue.js component code that interacts with our weather API. In this template, we define a layout structured with Tailwind CSS classes, ensuring our user interface is both functional and visually appealing. The input field is bound to the city data property using Vue's vModel, allowing for two-way data binding as users enter their city name. The button, which triggers the fetchWeather method when clicked, is styled to improve interactivity with Tailwind's background and hover classes. This button initiates the process of fetching weather data based on the user's input. Below the button, we have a conditional display of the weather information, which appears only if the weather data property is populated. This data is presented in a styled div that includes the current temperature and weather conditions related to the city specified. Finally, we handle potential errors by conditionally displaying an error message if the error property is set. This overall structure not only manages user input and output effectively, but does so in a way that enhances the user's experience through clean design and responsive functionality. Now let's take a look at how we can securely manage our API keys using an N file in our VUE.JS application with Vite. To begin, we need to create an N file in the root of our project directory where we'll store sensitive information like our API key. The format for this file is straightforward. We simply assign our actual API key to a variable, which we can name logically, such as VIT_API key. This helps in organizing our environment variables clearly. Next, we will implement the code that allows us to access this API key within our application. To do so, we can use the import metaenv VIT_API key syntax. This provides a secure way to reference the key in our API calls without hard-coding sensitive information directly in our source files. It's a best practice that not only enhances security by preventing key exposure in client-side code, but also allows for easy configuration changes between different environments, such as development and production. By following this method, we ensure our API keys remain hidden while still being accessible for necessary requests in our application. As we wrap up this discussion, remember that working with external APIs can greatly enhance your applications, providing users with valuable, real-time data. The ability to send requests and handle asynchronous data is a powerful tool in any developer's arsenal. We've covered how to make API calls, handle user interactions, display data, style our components, and manage API keys securely. Each of these skills builds upon the other, creating a robust framework for developing applications that can interact seamlessly with external services. So grab your eye, keep experimenting with external APIs, and let your application soar to new heights with dynamic data. Happy coding! Unit testing is a critical aspect of software development that ensures each component of your application is functioning correctly and meets the specified requirements. Today, we're diving deep into the world of unit testing, exploring why it's essential and how to implement it effectively in your projects. So far, we learned about external APIs and their importance in building interactive applications by fetching real-time data, such as weather information. We explored the process of making API calls using HTTP requests and handling the fetched data asynchronously in our applications. Additionally, we covered user interactions through input fields, error handling, styling with Tailwind CSS, and securely managing API keys. These skills are foundational for creating robust applications within the VUE.JS ecosystem and effectively integrating external services. Now we will talk about ensuring stability with testing, specifically focusing on unit testing. Now let's implement a simple function that calculates the sum of two numbers. The sum function takes two parameters, a and b, representing the numbers to be added together. When called, this function simply returns the result of adding a to b. This straightforward implementation serves as a fundamental example of a function in JavaScript, demonstrating how to process inputs and produce a result. Next, we will set up our testing environment for this function using Jest. To do this, we need to install Jest as a development dependency in our project by running the command to install it through npm. This step ensures that we have the necessary tools to write and run our tests effectively within our application. Now let's take a look at how to create our test cases in a dedicated file named sum.test.js. In this file, we will import the sum function and define a series of tests using Jest's test method. Each test will specify an expected outcome using expect along with the to-be matcher to assert that our sum function returns the correct result for given inputs. This structured approach helps verify that our function behaves as intended and allows for identifying potential errors in our implementation. Now let's see how we can implement a function to determine voter eligibility based on age. The isEligible2Vote function takes a single parameter, age, and returns true if the age is 18 or older, indicating that the user is eligible to vote. This simple logic is crucial for our application as it helps enforce voting regulations. Next, we need to ensure that our function behaves correctly across various scenarios. To achieve this, we will write several test cases using Jest, a popular JavaScript testing framework. In the test suite, we'll import the isEligible2Vote function and define three tests. The first two tests check for ages 18 and 20, both of which should return true. These tests verify that the function correctly identifies eligible voters. The third test examines an edge case by checking if someone aged 17 is considered ineligible, expecting the return value to be false. This thorough testing will provide confidence that our eligibility logic is functioning as intended, covering both normal and boundary cases to enhance the reliability of our code. Now let's take a look at a function that fetches user data from an external API. This function, fetchUserData, is defined as asynchronous to handle the potential delays of the network request. When called with a user ID, it constructs a URL to fetch the user data from a hypothetical API. The fetch function sends a request to this URL and awaits the response. Once a response is received, it converts the response into JSON format, allowing us to access the user data. The function then returns an object containing the user's ID, name, and email, effectively transforming the raw API response into a more manageable format for further use in our application. Next, we will write a test for this function using Jest to ensure it behaves as expected without relying on actual network requests. We begin by mocking the fetch function to return a predefined response. This allows us to simulate the API and test our function in isolation. Then we'll write a test case that validates whether the fetchUserData function returns the correct user information when provided with an ID. By mocking the response and running our test, we can verify that our data fetching logic works as intended, confirming the reliability of our implementation. Now let's see how we can implement a test for our asynchronous function, fetchUserData, using Jest. The purpose of this test is to ensure that the function correctly returns a user object with specific properties when called with a valid user ID. The test case is structured within the test function, which takes two parameters, a string description and an asynchronous function that contains the test logic. Inside this function, we await the result of calling fetchUserData with the user ID 1. We then use the expect function combined with toEqual to assert that the returned user object matches the expected structure. We define the expected object to have an id that is any number, a name that is any string, and an email that is also any string. This approach allows for flexibility in the actual values while ensuring that the returned object adheres to the required format. By setting up this test, we establish a clear expectation that fetchUserData will return an object with the correct properties when implemented, promoting the principles of test-driven development. Now that you grasp the core concepts of unit testing, let's discuss some best practices. First, keep your tests isolated. Each test should validate a single piece of functionality without dependency on others. This way, if a test fails, you can easily identify the block of code responsible for that behavior. Second, strive for clarity. Write your tests in a way that is easy to read and understand. Use descriptive names for your test cases and structure your tests logically. This practice not only helps your current team but also future developers who will interact with your code. Finally, consider running your tests frequently. Incorporate unit tests into your continuous integration, continuous deployment (CI/CD) pipeline to catch errors as soon as they are introduced. Automation tools can run your tests every time new code is pushed to the repository, ensuring that your codebase remains stable. Sometimes, despite careful planning and robust testing, you may find that bugs still seep through. To properly address these issues, use a technique known as debugging. Debugging allows you to inspect your code execution step by step, making it easier to identify the root cause of a failure. Most modern development environments come equipped with comprehensive debugging tools that let you set breakpoints, inspect variables, and step through code line by line. One common mistake while debugging is to assume where the problem is based solely on the test results. Instead, invest time in understanding the actual flow of your code and how data is processed. Use your debugger to check if the values being processed are as expected. It can often reveal underlying issues that aren't apparent just by reading the code. Take advantage of debugging features such as stack traces and error logs. They provide insights into where an error occurred and can guide you toward what needs to be fixed. This systematic approach to debugging helps maintain the reliability of your unit tests and overall application. Unit testing serves as a cornerstone in building reliable and maintainable software. By ensuring that each component functions as intended and meets specified requirements, you create a solid foundation for your applications. Along with fostering clear documentation and facilitating best practices such as TDD, unit testing can greatly enhance the quality of your code. Investing the time in writing tests and understanding how to implement them effectively will pay off in the long run. You'll build confidence in your code, speed up the development process by catching bugs early, and ensure a high-quality experience for your users. As we conclude our discussion on unit testing, remember that testing is not merely a final step in the development process. It should be an integral part of your workflow. By embedding testing into your coding practices, you're not just protecting your code from future bugs, you're enhancing your coding skills and contributing to a culture of quality in software development. Whether you're working on personal projects or collaborating in a team, adopting a testing mindset will elevate your work and set a strong example for others. So keep experimenting with unit tests, embrace the process of testing, and watch your development capabilities soar. Happy coding! Today, we'll explore the exciting and heroic world of app development by creating the Marvel Explorer app, which harnesses the power of the Marvel Comics API. Get ready to embark on a journey that will not only enhance your coding skills, but also allow you to interact with a massive database of comic heroes and stories. We will cover everything from setup to building components that fetch and display comic data. By the end, you will have a fully functional app ready to take users on a heroic adventure through the Marvel universe. So far, we have learned about the importance of unit testing in software development and how it assures the functionality of software components. We discussed setting up unit tests in JavaScript with Jest, covering synchronous and asynchronous functions, best practices, and the principles behind test-driven development, TDD. Now, we will dive into building an app using a third-party API, specifically the Marvel Comics API, and understand how to pull in and manipulate that data effectively. Now let's see how we can initialize our new Vue project and set up essential CSS styling. First, we use the pnpm init VUE.latest command to kick off the creation of our Vue application, which will serve as the foundation for our Marvel Explorer app. This command will prompt you to provide details such as the project name, which we will set to Vue Marvel Explorer. Next, we will install Tailwind CSS along with PostCSS and AutoPrefixer to enhance our styling capabilities, utilizing the command pnpm install dtailwinds post AutoPrefixer. Following the installation, we will run pnpm dlx tailwinds init p to create a new configuration file for Tailwind, ensuring we can customize our styles efficiently. Now let's implement the necessary configuration for Tailwind CSS. In the Tailwind config.js file, we define important settings that will allow Tailwind to purge unused styles during production, thus keeping our application lightweight. Additionally, we will create a style CSS file where we import Tailwind's base styles to apply a consistent look across our components. These steps lay the groundwork for a modern and responsive user interface, enabling a visually appealing experience as we display comic data from the Marvel API. Now let's take a look at the Tailwind CSS configuration that we'll use to style our Marvel Explorer app. The first part defines which files Tailwind should purify, ensuring that only the necessary styles are included in the final build, which helps keep the app lightweight and efficient. Next, we specify the content it should analyze in our project. This is crucial for optimizing our CSS during production. After configuring Tailwind, we need to create a style CSS file to import Tailwind's foundational styles, which include base styles, components, and utilities. These imports set the groundwork for consistent styling throughout our application. This allows us to leverage Tailwind's utility classes right away. Finally, we must include this CSS file in our main JavaScript file, which initializes our Vue application. By importing the style CSS file here, we ensure that all components have access to Tailwind's styling capabilities. This integration is key to creating a visually appealing and responsive interface while utilizing the power of Tailwind CSS in our app. Now let's take a look at how we can create our comic overview component using Vue. In this snippet, we begin by defining a template that conditionally displays loading messages while fetching data. The VIF directive is used to manage the loading state, allowing users to see a loading indicator while the comic data is being retrieved. Once the data is successfully loaded and the loading state is false, we render the comic titles in a responsive grid format using the Tailwind CSS classes for styling. Next, we delve into the script section where the Vue Composition API is utilized. We import essential functions such as ref and onMounted from Vue. These loading and data states are established using ref, making them reactive and allowing the template to respond to their changes. The getComics function is defined as an asynchronous function to fetch comic data from our specified API composable, useComics. This function is triggered when the component mounts, ensuring that comic data is fetched right away. By organizing our component this way, we encapsulate both the status of the API call and the display logic, thus maintaining a clean and efficient code structure as we proceed with the Marvel Explorer app development. Now let's implement the useComics composable in our src/composable/Marvel API TS file, which will streamline our interactions with the Marvel API. This function begins by importing the comics type, ensuring we have strong typing, which aids in maintaining clear and predictable data structures. We set the API key from our environment variables, which keeps our sensitive information secure and out of the public code. Next, we define the Marvel API endpoint, which will be used to fetch comic data. The useComics function is designed to return a promise of type comics. Inside the function, we use the fetch API to make an asynchronous call to the Marvel API, appending our API key to the URL for authentication. Once we receive the response, we pause it as JSON to extract the relevant data, which is then returned to be used elsewhere in our application. This structure not only encapsulates our data fetching logic, but also enhances the modularity and reusability of our codebase. Now that we have the data fetching logic in place, let's enhance the presentation of our comic data. We'll begin by creating the card view component, which will encapsulate the layout and styling for each comic item. This component features a simple template that uses a combination of Tailwind CSS classes to create a visually appealing card. It allows for dynamic content insertion through named slots. Specifically, we are using a slot for the header where each comic title will be displayed. Next, let's see how we can implement these cards in the Comics Overview View component to replace the simple title rendering. We update the template to use card view, iterating over the fetched data to create a card for each comic. Within our card, we leverage the slot functionality to inject the comic title as a header and display the comic's thumbnail image. This structured approach not only enhances the user interface but also promotes a cleaner and maintainable codebase by separating the card layout from the overview logic, ensuring that each piece of functionality has its distinct responsibility. Now let's implement the necessary updates to support pagination in our app. First, we modify our routing to include a page parameter which will allow us to navigate between different comic pages. This adjustment in the root configuration enables loading various comic pages based on the current URL, enhancing user experience by making the app more interactive. Next, we will adapt our useComics composable to accept a page number as a parameter. This is crucial as it changes the API request to include an offset calculated from the page number. By defining an items per page constant, we can dynamically adjust the data fetched from the Marvel API depending on which page the user is currently viewing. Finally, we will manage the page parameter within our Comics Overview View component. By utilizing a watcher that listens to root parameter changes, we trigger a fresh data fetch whenever the page number in the URL updates, ensuring that users see the correct comics as they paginate through the content. This seamless updating process maintains fluidity in user navigation and enriches the overall functionality of our Marvel Explorer app. Now that we have implemented pagination, let's create a pagination view component to facilitate navigation through the comic pages. This component includes buttons for the previous and next pages and displays the current page number. The template consists of a flexible layout with a button for the previous page, which is disabled if the user is on the first page. Similarly, the next button is disabled if the user is on the last page. Next, we will set up the script using Vue's Composition API. Here, we define properties to accept current page and total pages, which represent the current page number and the total number of pages, respectively. We utilize reactive references to track whether we are on the first or last page. The prev page and next page functions adjust the root of parameters, enabling seamless navigation between the pages. Finally, we implement a watcher that observes changes to the current page. This ensures that our buttons are correctly enabled or disabled in response to page changes, thus enhancing the user experience. With this implementation, users can easily navigate through the comic pages, making their journey through the Marvel universe more enjoyable. Now let's implement error handling to ensure our application gracefully manages potential issues that may arise during data fetching. In the useComics composable, we will wrap our fetching logic inside a try-catch block. This structure allows us to catch any errors that might occur, such as network failures or API issues. Inside the try clause, we continue to build our request as before, fetching the comic data from the Marvel API, while also managing pagination with the offset variable. If the response from the API isn't successful, we throw an error with a descriptive message which will provide clarity on what went wrong. After this, we enter the catch clause where we log the error to the console, enabling us to troubleshoot effectively during development. Instead of leaving the application in a broken state, we return an empty array, ensuring that the rest of the app can still function, albeit without displaying comic data. This robust handling allows users to be informed of underlying issues without experiencing confusion, as we can also add a simple error message in the comics overview view to notify users when data fails to load. And there you have it. We've built a fully functional Marvel Explorer app that fetches comic data from the Marvel API, implements pagination, and includes robust error handling. You've structured your application using Vue components and composables, making it easy to read, maintain, and expand in the future. To conclude, we not only created a cool app for comic enthusiasts but also practiced important concepts like modular design and error handling. The journey through coding is paved with challenges, and with each line of code, you're honing your skills to be a skilled developer ready to take on any project. Next time, we can dive deeper into adding more features or enhancements as you continue to explore the amazing world of app development. So gear up and get ready to embrace the possibilities with your newfound skills. In this tutorial, we're diving deep into data fetching and components, specifically focusing on how to extract data from APIs for our Marvel Explorer app. Get ready to enhance your app development skills. So far, we learned about the process of building the Marvel Explorer app using the Marvel Comics API, starting with setting up our project environment and initializing a Vue project. We configured Tailwind CSS for styling and create components to display comic data, implementing a card layout and pagination for user navigation. Additionally, we organized our code with composables and enhanced error handling to ensure a smooth user experience. Our journey has equipped us with valuable skills in app development, ready for future enhancements. Now we will talk about how to fetch data asynchronously from an API and effectively use components to display that data, allowing for a dynamic and interactive experience. Next, we will write the asynchronous function fetchComicsData, which is essential for retrieving data from the Marvel Comics API. This function begins with a try-catch block to handle potential errors gracefully. Inside the function, we utilize the fetch API to send a request to the Marvel Comics endpoint, including our API key. By using the await keyword, the function will pause its execution until the fetch promise resolves, allowing us to write cleaner and more readable code without falling into callback hell. If the response indicates a failure, i.e., response OK is false, we throw an error to be caught later in the catch block. Once we confirm that the response is successful, we pause the response body as JSON. The final step of the function returns the comic data contained in the results array. Should any errors occur during this process, whether due to network issues or invalid responses, they will be logged to the console, permitting easy debugging while ensuring that the app itself remains stable. This approach to data fetching enhances user experience by maintaining the app's responsiveness. Now let's implement the following component to showcase our comic data effectively. In our Comics Overview view, we define a template that provides a structured layout for displaying comics fetched from the Marvel API. We start with a title and conditional renderings to provide user feedback, showing a loading message while fetching data, displaying an error message if something goes wrong, or presenting the comics if data is retrieved successfully. Next, we establish reactive variables using Vue's ref to hold our comic data, loading state, and any potential error messages. The loadComics function plays a crucial role here. It's executed when the component is mounted, initiating the data fetching process. It updates the loading state, attempts to retrieve comics, and manages errors gracefully, ensuring the user is informed of any issues. After fetching the data, we ensure that the fetched comics are displayed within a grid layout by leveraging the v-for directive to iterate over the comics array. Each comic is displayed using the reusable CardView component, which we will enhance next, creating a clear and maintainable structure for our application while improving overall user interaction. Now let's implement the following CardView component, which will serve as the presentation layer for each comic in our application. This component utilizes Vue's single-file component structure, starting with the template section where we define the layout. Inside the template, we have an article element that provides a structured output with a white background and rounded edges, enhancing the card's visual appeal. We use a header section where we define a slot for the comic title, allowing for dynamic content insertion from the parent component, thus promoting reusability. Below the header we include an img tag that binds to the thumbnail URL prop. This prop will be passed from the comics overview component and will display the comics cover image, ensuring it is shown prominently. In the script section, we use the script setup syntax, which simplifies the component logic. Here we define a prop thumbnail URL, ensuring that the component handles this data input efficiently. This design keeps our components focused and encourages a clean architecture with a clear separation of concerns. By encapsulating the styling and layout for comic cards, we not only improve readability, but also make future modifications easier. Now let's implement error handling within our load comics function to enhance the user experience during data fetching. We begin by setting the loading state to true and resetting any existing error message to ensure clarity when the function starts. As we attempt to fetch comic data using the fetchComicsData function, it's crucial to handle the case where no comics are available. If the response yields an empty array, we assign a specific error message indicating that no comics are currently available. In the event of any issues during the fetching process, such as network errors, we catch these errors and provide a friendly message to the user. This message instructs them to check their connection and try again, ensuring they are not left without feedback. The finally block resets the loading state to false, indicating that the fetching process has concluded, regardless of its success or failure. This structured approach not only smooths out the user experience but also offers transparency regarding the application's current state, making it clear when they can expect to see their desired comic data or understand any issues that may arise. Now let's see how we can implement pagination in our data fetching logic. We start by modifying the fetchComicsData function to accept two parameters, offset and limit. The offset indicates where to begin fetching comics from, while the limit sets how many comics to retrieve in each API call. By default, we set offset to 0 and limit to 20, which means we will fetch the first 20 comics when invoked without arguments. In the try block of our asynchronous function, we construct the API URL with template literals to dynamically insert these parameters into the fetch request. If the response is not okay, we throw an error for better error handling. After successfully receiving the response, we pause the JSON and return the relevant comic data contained in the results array. Should any errors occur during the fetch process, we log an error message to the console to aid in troubleshooting. This implementation not only enhances performance by limiting data, but also lays the groundwork for a smooth pagination mechanism as we proceed to integrate this function into our Vue components. Now let's implement pagination controls in our Comics Overview Vue component, which will enhance user navigation through comic pages. In the template, we've added previous and next buttons that will allow users to move between the pages of comics. These buttons are dynamically disabled based on the current page state. For example, the previous button is disabled when on the first page, and the next button is disabled once the user reaches the last page. The pagination logic is managed through a reactive object, pagination, which keeps track of current page and last page. The loadComics function fetches data based on the current page, adjusting the offset to fetch the correct set of comics from the API. Each time a button is clicked, the relevant current page value is updated before calling loadComics, which refetches the data and reflects it in the UI. This implementation not only helps organize the comic display, but also enhances the overall user experience by facilitating smoother navigation through potentially large datasets. As we round off our exploration of data fetching and components, it's essential to reiterate the significance of effective error handling and communication in your app. With all the dynamic aspects built in, ensuring that users are informed about what's happening is paramount to a smooth user experience. Remember to keep your user messages clear and concise and always manage expectations. Whether it's through error messages or loading states, communicate what your app is doing to your users. To sum everything up, we have covered fetching data asynchronously from the Marvel API, integrating that data into Vue components, implementing pagination, and enhancing the user experience with proper error handling. Each of these steps contributes to building a solid, user-friendly application that provides true value to its users. As you continue to develop your skills in app development, don't hesitate to experiment further with these concepts, adding features, or even optimizing the performance of your application. Who knows, you might be the next great app developer that creates something remarkable with the skills you're honing right now. Now that you have a better understanding of data fetching and building components within your applications, it's time for you to put this knowledge to practice. Go ahead, dive in, and start building your very own applications harnessing the power of APIs and Vue. Happy coding! Now let's see how we can implement the error handling logic in our load comics function to enhance user experience. We start by setting the loading state to true, indicating that data fetching is in progress. Simultaneously, any previous error messages are reset to ensure that users start with a clean slate. Next, we employ a try-catch block around our API call, allowing us to gracefully catch and handle any errors that might arise during the fetch process. If the data fetching is successful, we check if the retrieved comic data is empty, and if so, assign a user-friendly message to the error state, informing users that no comics are currently available. In the catch block, we handle any errors that occur during the API interaction. A generic error message is assigned to the error state, guiding users to check their connection and try again. Finally, we reset the loading state in the finally block, signaling that the data fetching operation has completed, regardless of its success or failure. This comprehensive approach ensures our application not only maintains stability but also provides clear feedback to users, enhancing their overall experience when interacting with the app. Now let's implement the error notification in our template to ensure users receive clear feedback when something goes wrong. In this snippet, we introduce a conditional rendering mechanism using Vue's VIF directive, which determines whether to display the error message based on the presence of an error variable. When an error occurs, the div containing the error message will be displayed prominently, thanks to the Tailwind CSS classes we've applied. The BGRed500 class ensures the background color is a noticeable red, signaling an error to the user, while the TextWhite class guarantees that our text is clearly visible against this vibrant background. To enhance the overall aesthetics and usability, we also include padding with the P4 class and soften the edges using the RoundedMD class. Furthermore, we provide ample spacing around the div with the My4 class, ensuring it stands out from other elements on the page. This way, when users face an issue, they will immediately see a visually appealing error message, allowing them to quickly understand the problem at hand and take necessary action. In this case, we aim to create a user-friendly error handling experience. Now let's implement the following error notification template that enhances user interaction during fetch failures. In this template, we'll check if there's an error present. If there is, a visually distinct notification will be displayed to the user, featuring a bold red background and white text to ensure immediate visibility. This alerts users to the issue at hand, helping them understand why comics are not loading. Additionally, we've included a retry button within this notification. This button serves a critical function. When clicked, it triggers the load comics function again, allowing users to attempt fetching the comic data once more without having to leave the page. The button is styled with a contrasting appearance to make it easy to notice, yet it complements the overall theme of the application. This interaction design is focused on improving user experience. Instead of leaving users frustrated by an abrupt error message, this approach provides them with actionable feedback, encouraging them to retry the action and regain access to the comics they were exploring. In doing so, we transform a potentially negative experience into a more engaging and user-friendly one. Now let's incorporate proper error logging within our catch block for better debugging. By adding a console error statement, we effectively log the error details whenever an exception occurs during the comic data fetching process. This way, developers have immediate access to the error message and stack trace, enabling them to understand what went wrong behind the scenes without exposing sensitive information to the users. Additionally, we gracefully inform users of the issue through a user-friendly error message. We achieve this by constructing a message that briefly explains the error while suggesting they try again. This dual approach enhances our application's resilience. Developers can debug efficiently, while users receive helpful feedback without feeling overwhelmed. Furthermore, this logging system allows us to track errors systematically, paving the way for integrating third-party services like Sentry or LogRocket that can help monitor and analyze these error reports over time. By taking this step, we not only improve the application's maintainability, but also foster a smoother experience for our users, ensuring they feel supported even when unexpected issues occur. Now let's take a look at how we can test our error handling logic in the application. We begin by writing a test case that ensures our code appropriately handles fetch errors. In this test, we use jest to mock the globally defined fetch function, simulating a network error by making it return a rejected promise. This allows us to recreate the conditions under which our application might fail due to a fetch issue. Next, we call the loadComics function, which is the same function responsible for fetching comic data from the API. After this function executes, we check that the error state in the application reflects the expected error message when a fetch failure occurs. Specifically, we expect it to display a user-friendly error message indicating that the data could not be loaded due to a network error. Finally, it's crucial to restore the mock implementation of fetch to avoid affecting other tests. This approach demonstrates how effective testing can ensure our error handling is robust and functions correctly, providing a seamless experience for users even when the backend encounters issues. As we wrap up our discussion about error handling strategies, it's clear how critical this aspect is in application development. Establishing a robust error handling strategy ensures not only that we create a stable application but also enhance the overall user experience. Now, as you move forward with your own applications, remember to think about your users. They may not understand the nuances of your code or the complexity of API interactions, but they will appreciate clarity when issues arise. By implementing user-friendly error messages, providing retry options, and logging backend errors for developers, you're setting your application up for success. In the ever-evolving landscape of web development, where external factors often influence performance, being prepared for errors is the best strategy you can adopt. Take this knowledge and iterate on it, ensuring that your applications provide a seamless experience even when things don't go to plan. Now it's time for you to implement these strategies. Happy coding, and let's make our applications as robust and user-friendly as they can be. Starting today, we're diving into an exciting journey of leveraging a third-party component library to build a robust user interface for our meal planner application. We'll guide you through the process of harnessing the power of such a library while maximizing the management of our application's state using stars securely integrated with VUE.JS. So far, we learned about the importance of user-friendly error handling in application development, specifically when integrating with the Marvel Comics API. We discussed crafting an asynchronous function that utilizes try-catch blocks to manage API interactions, gracefully handle errors, and provide meaningful feedback to users. Additionally, we highlighted the necessity of visual error notifications and actionable feedback, enhancing user experience and ensuring that our error handling logic remains robust through rigorous testing. Now, let's talk about how we can take our app to the next level. In this session, we'll cover the necessities of applying and customizing Vuetify to get a quick start on the user interface while exploring how to structure and manage our application's state effectively. Now let's implement the core functionality of our application using Pinia for state management. First, we start by defining our caching store, which is essential for optimizing data retrieval in our meal planner. This store will hold cached data, allowing us to reduce unnecessary API calls. In the store, we create two key functions: cached data for retrieving cached values and cached data for storing results with a unique key, which helps manage our application's performance effectively. Next, we'll focus on integrating this caching mechanism when fetching recipe details. We design a method that first checks if the requested recipe data is already in our cache. If it's not, we proceed to call an assumed function that fetches data from the API. Once we receive the data, we utilize our caching function to store it, ensuring it can be quickly accessed in future requests, which leads to a swift and seamless user experience. This approach not only improves performance but also enriches user interaction by minimizing loading times. Now let's implement a straightforward button component using Vuetify, which simplifies our tasks while enhancing the user interface. In this line of code, we see the VBTN component, where color equals primary provides built-in styling, assigning the button a primary color as defined by our Vuetify theme. This makes it immediately recognizable and consistent with our application's color scheme. Additionally, we have an event listener denoted by @click equals add recipe that binds a click event to our button. This means that once users click the button, it will trigger the add recipe function we plan to define later in the tutorial. This approach not only streamlines the code, but also allows us to maintain a clean separation between the user interface and the underlying logic that handles the action. By leveraging VUE.JS, we can rapidly create functional and visually appealing components without getting bogged down in manual styling and event management. Through this, we maximize our productivity and focus more on developing unique features for the meal planner application. Now let's see how we can enhance our Vue application by integrating Pinia for effective state management. First, we need to install Pinia, which allows us to create a centralized store for managing the shared state across components. By running the installation command, we add Pinia to our project dependencies. Next, we will incorporate Pinia into our application by modifying the main.ts file. We begin by importing the createPinia function from Pinia, which is responsible for setting up the store. After creating an instance of the store with createPinia, we proceed to use it in our Vue application by calling app.usePinia. This step is crucial, as it ensures that the entire application can access the Pinia store. Finally, we mount our application to the DOM with app.mount#app, making our state management capabilities functional throughout the app. By completing these configurations, we successfully link Pinia to the Vue application, setting the stage for defining and managing state across our components easily and effectively. This foundational step is essential for maintaining a responsive and organized state in our meal planner app. Next, we'll implement our caching store, which will optimize our application's performance by minimizing unnecessary API calls. The code begins by importing necessary functions from the Pinia library in Vue. We utilize the defineStore function to create our cache store named cache. Inside this store, we define a reactive reference called cache to hold our cache data as an object. Now let's see how we can implement two key functions, cache data and cache data. The cache data function accepts a unique key and checks if there's data stored with that key. If found, it returns that data, otherwise it returns null. This function allows us to efficiently retrieve previously fetched data, significantly reducing loading times for the user. Next, the cache data function enables us to store new data in the cache using a specified key. Whenever we have fresh data that we want to remember for future use, we can invoke this function, ensuring that the application can serve users efficiently by utilizing the cached information instead of making additional API requests. Together, these functionalities form the backbone of our caching strategy, enhancing user experience throughout our meal planner application. Now let's implement the caching strategy when fetching recipe details. In the defined asynchronous function, getRecipeDetails, we start by creating a unique key for accessing cached data based on the recipe ID. The first step checks if the data associated with this key exists in the cache. If it doesn't, we proceed to fetch the recipe data from the API, assuming there's a function managing the API calls. Once the data is retrieved, we cache it for future use. This caching mechanism is crucial for improving performance, as it prevents redundant API calls for data that's already been fetched. By setting the recipe data to a reactive property, we ensure that any changes are automatically reflected in the user interface. If the recipe details are already cached, we simply retrieve them from the cache and display them to the user. This approach not only enhances the speed of our application, but also provides a smoother user experience by reducing load times when users navigate back to previously accessed recipes. This caching implementation showcases the effectiveness of smart data management within our meal planner application. Now let's implement the following functionality for managing our recipes within the meal planner application. We begin by defining a new Pinia store called usePlannerStore, which will serve as the centralized state management for our recipes. This store leverages the ref function from Vue to create a reactive variable called recipes, which utilizes useLocalStorage to ensure that our list of recipes is stored persistently on the user's device. This means that even after refreshing the page, users will retain their recipe selections. Next, we introduce two essential methods, addRecipe and removeRecipeByAdd. The addRecipe function allows users to append new recipes to their recipes list, enriching their meal planning experience by letting them select from a wider variety of dishes. Conversely, removeRecipeByAdd helps users remove a recipe based on its unique identifier. This method filters the existing recipes and returns a new array excluding the specified recipe, ensuring a clean and manageable state. By utilizing this star, we not only maintain an updated list of recipes but also enhance the user experience by allowing seamless modifications that are retained even across sessions. Finally, let's put everything together and interface these stars with our main Vue components. We'll build a recipe calendar view that references our stars, rendering available recipes for selection and planning. This integration is seamless due to the reactive capabilities of Vue, where anytime we modify our star's state, Vue updates the linked components automatically. By now, you should have a solid foundation to effectively use a third-party component library like Vuetify in tandem with a state management solution like Pinia, making your VUE.JS applications more powerful and user-friendly. Tune in for the next installment, where we'll continue to build upon our meal planner and explore the intricacies of data management and API interactions detailed in our journey. It's going to be a whole lot of fun. Now let's implement the calendar card component, which displays individual meals for our meal planner application. First, in the template section, we create a Vuetify card layout using vcard, which includes a title that shows the recipe's name from the props and a subtitle that displays the formatted date. This formatted date is generated through a computed property, ensuring it updates dynamically whenever the recipe data changes. The vcard actions section includes two buttons, one for editing and another for deleting the recipe. Each button is linked to a corresponding method, making the user experience interactive and straightforward. In the script section, we import the required functions from Vue, along with our date formatting utility. The formatted date computed property leverages the format date function to process and present the date in a user-friendly format. Next, we define the edit recipe and remove recipe methods. While these methods currently log actions to the console, they are placeholders for handling state changes and user interactions. By structuring our component this way, we maintain a clear organization and prepare for future enhancements. Now let's implement the following code in our meal planner Vue component, where we'll build the main meal planner interface. This component begins with a template that leverages Vuetify's responsive layout systems, specifically vcontainer, vrow, and vcall. The vrow iterates through the recipes array sourced from our planner star, enabling us to dynamically render a calendar card for each recipe. By passing the recipe object as a prop to the calendar card, we ensure that each card receives the necessary data to display key information and interact with the user. Next, we'll dive into the script section where we define the component using Vue's define component. We begin by importing essential dependencies, including our usePlannerStar function from the star. Within the setup function, this star is invoked to access and retrieve the recipe's state, which we then return for use in the template. This design not only organizes our code, but also ensures that our component is efficiently reactive to any changes in the recipe list. With these functionalities, we are setting the stage for a powerful and user-friendly meal planner application. Now let's take a look at how we enhance the calendar card component to include a deletion confirmation dialog using Vuetify. Within the template section, we incorporate a vdialog that triggers upon clicking the delete button. This dialog is bound to a reactive variable named dialog, which controls its visibility. When the user chooses to delete a recipe, the confirmDelete method is invoked, setting dialog to true and displaying the confirmation message. Next, we define the logic for the remove recipe function. When the user confirms deletion by clicking yes, it logs the action to the console, and in a real application, this is where we'd implement the logic to actually remove the recipe from the planner star, thus updating the application's state accordingly. If the user clicks no, the dialog simply closes without any changes being made. By integrating this deletion confirmation dialog, we significantly improve the user experience, ensuring that users make intentional choices before removing items from their planner. This promotes better interaction and reinforces the importance of confirming significant actions in user interfaces. As you can see, building a dynamic user interface in Vue using Vuetify can be an exciting journey filled with various components that enhance user experience. The calendar card we created not only displays essential information, but also provides interactive elements for managing recipes through confirmation dialogues. By creating reusable components like calendar card, you ensure your application remains organized and manageable as it grows. The use of props and events allows for modular design and a clearer architecture, enabling you to add more features in the future with minimal effort. To recap what we've covered, we've walked through the process of creating a calendar card component to display meals, integrating a date formatter, and implementing user interactions through action buttons. We also enhanced functionality by including a confirmation dialog for deletion. Moving forward, you're now well equipped to create visually appealing and interactive components using VUE.JS. Keep this foundational understanding of UI design principles in mind as you continue refining your meal planner application. In our next session, we'll explore further into data management, enhancing how to handle more complex interactions within your application. Stay tuned and happy coding. Now let's see how we can implement our state management solution using Pinia. We begin by importing the defineStar function from Pinia, which is essential for creating our star. Next, we define an interface called recipe, outlining the structure of our recipe objects to include an ID, title, and date. This definition helps us ensure that every recipe managed in our star adheres to this consistent structure, enhancing type safety. Now let's create our star by calling defineStar and passing planner as the name. Inside this star, we define our state, which is represented as a function returning an object. This object holds our car state, a recipes array, initially set to an empty array. Next, we declare our actions, which are functions designed to modify the state. We've implemented two actions: add recipe, which adds new recipes to the array, and remove recipe, which filters out recipes by their ID. Lastly, we set up our getters. getAllRecipes returns the full recipes array, while getRecipeById fetches a single recipe based on an ID, allowing components to retrieve data conveniently while maintaining a clean and modular code structure. Now let's implement the meal planner view component to leverage our planner star for effective state management. First, we define the component structure using Vue's template syntax, where we create a container that houses the title and a grid layout for displaying recipes. Next, we import the usePlannerStar function from our star, which allows us to pull in the state and methods we need. Inside the setup function, we access the star by calling usePlannerStar, allowing us to interact with the star data seamlessly. In the return object of the setup function, we expose the recipes variable, which is bound to the getAllRecipes getter from the star. This setup provides us with a clean and reactive way to access the list of recipes for use in our component. Within the template section, we utilize Vue's v-for directive to iterate over the recipes, displaying each one with the calendar card component. This approach not only keeps the component's logic clear, but also takes advantage of Vue's reactivity and the power of Pinia for state management, enhancing maintainability as our application expands. Now let's see how we can implement the addRecipe view component, which allows users to dynamically add recipes to our meal planner. We start by creating a template that includes a form using Vueify components, ensuring a user-friendly interface for inputting recipe details. Within this form, we utilize vModel to establish a two-way binding between the input fields and the title and date references, making them reactive. Each input field is accompanied by validation rules to ensure that both the title and date are populated before submission, enhancing data integrity and user experience. Next, we'll define the submitRecipe function, which triggers when the user attempts to add a new recipe. Inside this function, we first check if the form is valid. Once validated, we create a new recipe object, assigning it a unique ID generated using date. Now, a simple approach suitable for development, but we'd want to consider a more robust method in production. After constructing the new recipe object, we call the addRecipe action from our PlannerStar to add this recipe to our state. Finally, we clear the input fields, resetting them for the next entry. This structure not only keeps our application organized, but also allows for easy scalability as we build more features. With this, we have covered the core of managing application state using Pinia. We created a dedicated PlannerStar for our meal planner application to encapsulate the state of our recipes, actions, and getters. We then integrated this star into our components, ensuring clean and manageable code, important as our application grows in complexity. To wrap up, effective state management is foundational to developing scalable and maintainable applications. Pinea provides a user-friendly interface for managing state in Vue applications while ensuring that our components remain clean and focused on rendering the UI rather than managing the underlying data logic. By following the patterns discussed today, you are equipped to incorporate robust state management within your own applications. As you continue refining your meal planner, consider how effectively managing state can lead to an enhanced user experience. Stay tuned as we further refine our application and explore more features, including handling user authentication, advanced data manipulation, and more sophisticated interactions. Happy coding! Up until this point, we've learned how to manage application state effectively using Pinea for our meal planner app, focusing on creating the planner star to handle recipes. We implemented actions for adding and removing recipes, and used getters to access the state easily. Additionally, we integrated the planner star into the meal planner component and developed a new add recipe component to allow users to input their recipes dynamically. This sets up a solid foundation for further refining the application and enhancing user experience. Now we will talk about fitness tracking and understand how it has evolved as a crucial component of our daily lives. Fitness tracking encompasses a plethora of devices, applications, and methodologies aimed at monitoring physical activity and health metrics. With the rise of technology, it has become increasingly easier to access this wealth of data, enabling users to take charge of their health. Fitness trackers, mobile apps, and smart wearables can now monitor everything from steps taken and calories burned to heart rate and sleep patterns. At its core, fitness tracking is about understanding how we move and live, and using that understanding to make positive changes in our lifestyles. Now let's see how we can implement a function to log daily steps in our fitness tracking application. This function, named logSteps, begins by attempting to retrieve any previously logged steps from the local storage, utilizing JSON to convert the stored JSON string back into a JavaScript object. If no previous log exists, it initializes steplog as an empty array. Next, the function appends a new object to steplog, which contains the current date formatted in ISO style and the number of steps recorded. This is achieved using newDate to ISO string, split T0, to ensure a clear, standardized date format. Finally, local storage setItem is called to save the updated steplog back into local storage as a JSON string, ensuring that the new data persists for future use. This approach illustrates the basic mechanism of managing user data within a stateless environment. However, it's important to recognize the limitations surrounding local storage, particularly when it comes to scalability and data accessibility across multiple devices. Understanding these constraints sets the stage for developing more sophisticated, stateful applications in the future. Now let's implement a backend service to log daily steps using Node.js and Express. First, we require necessary modules: Express, which handles our web server, BodyParser for parsing incoming request bodies, and PG to interact with our PostgreSQL database. After setting up our Express application, we establish a connection to the database using a pool from the PG module, providing the necessary credentials to connect. Next, we use BodyParser to parse incoming requests in JSON format, ensuring that our application can handle the data sent by clients. Now, let's define a post endpoint at logSteps. Within this endpoint, we extract the user's ID and the number of steps from the request body. We also generate the current date in the ISO format to record when the steps were logged. Following this, we prepare a SQL query to insert the user's step data into the database. In a try-catch block, we execute this query using the pool's query method. If the insertion is successful, we respond with a success message. If there's an error, we handle it by sending an error message to the client. Finally, we start our server on port 3000, allowing it to listen for incoming requests. Now let's see how we can implement a dynamic chart to visualize daily step counts using Chart.js. First, we create a canvas element with a specified width and height, which serves as the drawing surface for our chart. The script begins by loading the Chart.js library through a CDN to ensure we have access to its powerful charting functions. Next, we obtain the drawing context from the canvas element, allowing us to create the chart. We prepare an array called step data that holds sample step counts for each day of the week. Using this data, we construct a new chart instance, specifying that we want to create a line chart. The data property defines the labels for each day, Monday through Sunday, and organizes the step data into a dataset labeled steps taken, which is styled with a specific border color and width. Finally, we configure options for the chart, particularly ensuring that the y-axis begins at 0 for a clearer representation of step counts. By executing this code, users can effectively visualize their activity trends over the week, providing valuable insights into their fitness journey. Now let's see how we can implement a function to fetch heart rate data from a wearable fitness device's API. In this code snippet, we define an asynchronous function named fetchHeartRateData that takes a userid as an argument. This function utilizes the fetch API to make a request to a specific URL that contains the heart rate data for the specified user. Upon calling this URL, the function awaits the response and then processes it to convert the data from a JSON format using response, JSON. Once the data is retrieved, the function returns this parsed data for further use. This approach not only allows for easy access to real-time heart rate information but also simplifies error handling, as the use of asynchronous operations prevents the application from freezing while it waits for the response. Next, we see an example of how to invoke this function, where we pass a sample user ID. The resulting heart rate data is then logged to the console, enabling developers to easily visualize and troubleshoot the data being fetched. This process streamlines the integration of real-time metrics into our fitness tracking application, greatly enhancing user engagement and experience. Now let's delve into a simple implementation of a recommendation system based on users' activity levels. The code introduces an object called ActivityLevels, which categorizes users' activity based on the number of steps they take daily. Each category, low, medium, and high, contains a motivational message intended to encourage users to either increase their activity or celebrate their achievements. Next, we will write the recommendActivity function, which takes the number of steps as an argument. Inside this function, we use conditional statements to determine the user's activity level. If the steps are less than 5,000, the function returns the low message, suggesting users might want to add light exercises. For those who achieve between 5,000 and 9,999 steps, the medium message is returned, affirming their efforts. Finally, if users hit 10,000 steps or more, they receive the high message, encouraging them to consider new challenges. This approach effectively uses small motivational nudges to inspire users along their fitness journey, helping them stay engaged and motivated to enhance their habits. As we explore further, it's worth reflecting on the future of fitness tracking. The convergence of fitness tracking and health monitoring is becoming increasingly prevalent. Innovations in health tech are enabling devices not only to observe fitness metrics but also to provide critical health insights, such as abnormal heart rhythms, blood pressure monitoring, and even sleep apnea detection. With advancements in artificial intelligence and data analytics, fitness tracking applications can provide deeper insights into overall well-being, effectively becoming personal health assistants. The richness of data allows for more proactive health management, which can lead to better outcomes. Looking ahead, the integration of blockchain technology may revolutionize fitness tracking by enhancing data security and giving users ownership of their health information. This means individuals can retain control over their data and share it selectively with healthcare professionals as needed, further personalizing their health journeys. In summary, fitness tracking has evolved from simple stateless applications into comprehensive stateful systems capable of real-time data processing and deep analytics. We've covered how to log fitness data, visualize it, connect with wearable devices, harness machine learning for personalization, and reflect on the future of this burgeoning field. This knowledge paves the way for developing advanced applications that not only track users' fitness metrics but also empower them to lead healthier lives. As technology continues to advance, fitness tracking can transform from a passive data collection tool into an active partner in our health journeys. So gear up, because the next time you lace up those sneakers, you'll be ready to take full advantage. In today's lesson, we're diving into the exciting world of utilizing Supabase for data storage. Supabase is a powerful platform that simplifies the process of building applications with a backend using PostgreSQL. We'll explore how to create and manage dashboards, retrieve data, store it efficiently, and visualize it with VUE.JS. So far, we learned how to effectively manage application state in our meal planner app using Pinia, exploring the creation of the planner store for recipes. We also touched on the evolution of applications from stateless to stateful, which underpins how we track real-time data. Now, let's unpack how Supabase takes the hassle out of data storage. Supabase is often referred to as an open-source Firebase alternative, but what does that actually mean? The core idea is that Supabase enables developers to create, manage, and interact with databases without needing extensive backend expertise. By foundations built on PostgreSQL, you can leverage powerful relational database capabilities from the get-go. Imagine having a fully managed database complete with authentication and real-time capabilities, all integrated seamlessly into your app. Whether you're managing user data for a fitness tracker or logging recipes in a meal planner, Supabase can handle it efficiently. Now let's see how we can implement the creation of our recipes table in Supabase. The SQL command we will use is designed to create a new table named recipes, which will hold all the essential information about each recipe we want to store. The first part of the command defines an id column as a primary key, ensuring that each recipe has a unique identifier. This column is set as a serial type, which means Postgres will automatically generate a sequential value for it. Next, we include a name column to store the recipe names, which is defined as a variable character type with a maximum length of 255 characters. Additionally, we use an ingredients column of type text to capture all the ingredient details in a single field, making it easier for users to input long lists without worrying about length limitations. Lastly, the instructions column, also of type text, allows us to store detailed cooking directions, ensuring users can follow the recipe smoothly. Once you execute this command in the Supabase table editor, the recipes table will be ready for use in our application. Next, we'll install the Supabase client library, which is essential for connecting our application to Supabase and performing database operations. This is done via npm with a simple command that fetches the library and adds it to our project dependencies, ensuring that we can utilize its features seamlessly in our application. Now that we have the library installed, let's set up our Supabase client in a new file called Supabase client.js. Here we import the create client function from the library, which allows us to create a Supabase client instance. We then define the Supabase URL, which includes our unique project reference, and the Supabase key, which is our public anonymous key. This setup is critical since it establishes the connection between our app and the Supabase backend. Finally, we export the Supabase instance, making it readily available to the rest of our application. This client will enable us to perform various operations like inserting, updating, and fetching data from our database effortlessly. Now that our Supabase client is ready, let's explore how to store user-submitted recipes in our database. We'll implement an addRecipe function that takes the recipe name, ingredients, and instructions as parameters. Within this function, we utilize the Supabase client to insert a new entry into the recipes table using the insert method. It's important to construct the data in the expected format, which requires wrapping the parameters in an object. Next, we handle the response from Supabase, which returns either the newly created recipe data or an error. If an error occurs during the insertion, we log it to the console to help with troubleshooting. However, if the operation is successful, we confirm the addition by logging a success message, along with the data received. This function encapsulates the process of adding a recipe, ensuring that user inputs are seamlessly stored in our database with clear feedback on the success or failure of the operation. Next, we will look at how to retrieve recipes from our Supabase database. We begin by defining an async function called fetchRecipes. This function uses the Supabase client to interact with the recipes table, specifically calling the select asterisk method to fetch all columns of data available. The beauty of using Supabase is its ability to handle both the retrieval of data and error management seamlessly. If an error occurs during the fetch operation, the function logs the error to the console for easy debugging and returns an empty array, ensuring that your application can function correctly even when issues arise. Once the data is successfully fetched, it's returned as the function's output, allowing it to be utilized within your application. This is particularly useful when you want to display recipes dynamically to users, making it a crucial part of the data interaction layer of your meal planner app. The structure of this function exemplifies how clean and efficient working with Supabase can be, reinforcing the ease of managing database operations without extensive backend knowledge. Now let's implement the following installation command to add the necessary libraries for visualizing our recipe data. By using npm, we can easily install VUE.JS along with chart.js, which will provide us with the tools needed to create interactive charts in our application. Next, we will write a recipe chart component that encapsulates the bar chart we want to display. Within the template, we'll reference our custom bar chart component, which is derived from VUE.JS. Now let's see how we can set up the script section. We import the required modules including the bar component from VUE.JS and the reactive ref and lifecycle hook unmounted from Vue. In the setup function, we define a reactive chart data object that holds our charts labels and data sets. Upon mounting, we'll fetch the recipes using our previously implemented fetchRecipes function. This asynchronous call retrieves the recipes from our Supabase database, and we dynamically populate the charts labels with the recipe names. Additionally, we calculate the number of ingredients for each recipe and set that as data for our chart, allowing us to visualize the ingredient count effectively. Now let's explore how we can update a recipe in our Supabase database using a dedicated function. We'll implement the updateRecipe function, which takes two parameters, the recipe's ID and the updated details that we want to apply. This function utilizes Supabase's update method to modify an existing record in the recipes table. When we call this function, it first attempts to update the recipe with the given ID by applying the changes specified in updated details. If the update process encounters an error, we log the error message to the console, allowing us to diagnose what went wrong. However, if the operation is successful, the function provides feedback by logging a success message along with the updated recipe data. This straightforward and efficient approach mimics the insert and fetch functionalities we previously discussed, making it easy to manage recipe updates as your application evolves. The simplicity of handling updates through this method emphasizes the ease of use that Supabase offers for maintaining your application's data. Now let's implement the deleteRecipe function, which allows us to remove a specific recipe from our database. This function takes an id parameter representing the unique identifier for the recipe we want to delete. Inside the function, we utilize the Supabase client to call the fromRecipes method, specifying that we are working with the recipes table. We then use the delete method to indicate our intention to remove a record, followed by the id method to filter down to the specific recipe that matches the provided id. This ensures that we're targeting the correct entry for deletion. After executing the delete operation, we handle the response by checking for any errors. If an error occurs, we log it to the console to help with troubleshooting. Otherwise, we confirm the successful deletion by logging the return data. This straightforward function is crucial for managing the data lifecycle in our application, allowing us to remove recipes as needed. Now let's implement the user registration functionality. First, we define an asynchronous function called signup, which takes the user's email and password as parameters. Inside the function, we call Supabase's signup method to create a new user account. This method returns an object that includes the user details, session information, and any errors that may have occurred during the signup process. If there's an error, we log it to the console for debugging purposes. On successful signup, we celebrate by logging the user's details, confirming that they have signed up successfully. Next, we will write the login function for users. We create another asynchronous function named login, which also accepts email and password parameters. This time we leverage Supabase's sign-in method, which checks the credentials against the existing user base. Similar to the signup function, this method returns user information or an error. Again, we handle errors by logging them while providing feedback on successful logins. By implementing these two functions, we enable secure access to our application, ensuring users can register and log in to access their data safely. As we wrap up our exploration of Supabase, it's essential to emphasize why leveraging a service like this can streamline the development process. By providing managed relational data storage with real-time capabilities, authentication, and robust APIs, Supabase allows developers to focus more on building rich app features rather than on backend complexities. In summary, today we discussed how to set up a Supabase project, create tables, store and retrieve data, visualize it with VUE.JS, and handle user authentication. All of these capabilities provide a powerful toolset for developers looking to implement full-featured applications swiftly and efficiently. So whether you're building a meal planner app or a fitness tracking system, Supabase can help transform your ideas into reality with simplicity and professionalism. Happy coding! Now let's implement the setup for our recipe chart Vue component, which is dedicated to visualizing our recipe data. We start by importing the required components from VUE.JS and the Vue composition API functions for reactivity and the lifecycle hook. Inside the setup function, we initialize two reactive objects, chart data for our bar chart and line chart data for our line chart, both starting with empty labels and datasets. Next, we use the unmounted hook to fetch the recipe data from our Supabase database asynchronously. This is where we populate our charts. For the bar chart, we map over the recipes to extract their names and count the number of ingredients by splitting the ingredient string. We then structure the dataset for the bar chart with these values. Similarly, for the line chart, we prepare the cooking times. This reactive setup ensures that when we modify our data, the charts will update accordingly. As a result, we create engaging and interactive visualizations that enhance user experience in our application. Now let's take a look at how we can effectively manage our ingredient data for better visualization. In our setup function, we begin by mapping over the recipes array to transform each recipe's ingredients field into an array, splitting the string at each comma. This allows us to accurately determine the number of ingredients for every recipe, which is essential for our visual analysis. Next, we can enhance our insights by calculating the average number of ingredients per recipe. We achieve this by using the reduce method to sum up the lengths of each ingredient array and dividing by the total number of recipes. This average can give users a quick glance at ingredient diversity across the dataset. Finally, to display this calculated average in our template, we can use template interpolation, which allows the dynamic rendering of our average value in the HTML. This approach not only enriches the user experience by providing instant feedback, but also maintains a clear and structured flow of data processing, paving the way for an engaging and informative visualization experience within our application. Now let's implement the refresh data method to ensure our charts seamlessly update with the latest recipe information from our database. This method fetches the most current recipes by calling the fetchRecipes function, which retrieves the data stored in Supabase. Once we have the updated recipes, we can process this data to extract relevant details for our visualizations. We achieve this by mapping over the retrieved recipes to determine the number of ingredients for each one. This is done by splitting the ingredients string at each comma and counting the resulting array's length. Simultaneously, we collect the cooking times, ensuring we have all necessary data for our charts. Next, we directly assign the processed values to the corresponding datasets of our charts. The ingredient counts are assigned to the first dataset of chart data, while the cooking times populate the first dataset of line chart data. This refresh mechanism is crucial because it guarantees that any updates in our recipe data, whether additions, modifications, or deletions, are reflected in real time within our visualizations, thus keeping the information current and engaging for users. Now let's take a look at how we can implement a form that allows users to add new recipes directly to our application. We start with a template containing a form, utilizing the @submit_prevent directive. This prevents the default form submission behavior and allows us to handle the form submission through a method we define next. Inside the script, we import necessary functions from Vue and our database service. We define reactive properties for the recipe's name, ingredients, and cooking time, ensuring that any changes to these inputs will trigger updates in the UI. Next, we'll implement the addRecipe function as an asynchronous method. This function performs two crucial tasks. First, it submits the new recipe data to the Supabase database, and then it calls the refresh data method we created earlier to immediately refresh our charts with the new data. Afterward, we reset the form fields to prepare for the next input. In this way, users can seamlessly add recipes and see updates in real time, enhancing the interactivity and responsiveness of our application. Now let's implement the interaction features in our charts. We will enhance our datasets in the chart data configuration. Specifically, we're adding tooltips that provide more context when users hover over different elements of the chart. This is achieved through the tooltip callbacks, which allow us to customize what information is displayed. For instance, when a user hovers over a bar representing the number of ingredients, the tooltip will show the exact count by referencing tooltip_item_label. Additionally, we've included a hover background color property to give a visual cue when users hover over the data points. This color change will help to engage users further and make the chart more interactive. The tooltip customization fosters a user-friendly experience, enabling quick insights into the data without requiring additional clicks or navigations, effectively enriching user interaction with our application's visual data representations. Integrating these features not only makes the charts more informative, but also enhances the overall user engagement with the data visualization component in our meal planner application. Now let's take a look at how we can customize our chart.js options to enhance the visual appeal of our charts. The options object allows us to define various properties that control the responsive behavior and styling of our charts. For instance, we set responsive to true, ensuring that the charts adjust their size according to the viewport. Next, we focus on scaling the axes where the y-axis begins at 0, which is important for better data representation. We can define the color of the grid lines to a subtle shade, such as E0, 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 making them less intrusive while still guiding the viewer's eye. Additionally, we can customize the appearance of tick marks on both axes. For example, we adjust the font size to 14, select Arial as our font family, and set the font weight to bold, improving readability and ensuring that our data presents itself clearly. By applying these customizations, we not only improve the overall aesthetics but also enhance user engagement, making the charts more aligned with the theme of our application while ensuring clarity in the information presented. This attention to detail in styling is key to delivering an attractive and functional data visualization component. In summary, we explored how to implement data visualization in our meal plan application using VUE.JS and Nuxt.js. We covered not only the setup of dynamic charts, but also the crucial process of data manipulation for effective visual representation. We discussed how to handle user input to update our visualizations in real time and improve user interaction through tooltips and styling options. Implementing such data visualization will not only enhance the aesthetic quality of our application, but also provide users with powerful insights into their recipe management. This approach ensures that data is not merely static, but is alive and engaging. So now, go ahead and apply these techniques in your projects. You'll be amazed at how simply visualizing data can elevate your applications. Happy coding and visualizing. Now let's talk about expense tracking. An effective expense tracker helps individuals and businesses manage their finances by organizing expenditures into different categories. It's not just about knowing how much you spend, it's about understanding your spending behavior so you can make informed financial choices. In this lesson, we are diving into the essentials of expense tracking, how to structure it in your application, and how to keep data organized using categories. So far, we've learned about utilizing Supabase for data storage and implementing data visualization techniques in our meal plan application. We explored how to set up VUE.JS for creating bar and line charts to represent recipe data, including handling user authentication and real-time updates. Additionally, we discussed the importance of data manipulation for effective visualization and enhancing user interaction through tooltips. Finally, we emphasized customizing chart aesthetics to improve user engagement and readability. Now, we will cover how to implement expense tracking effectively in your application. Now let's see how we can implement the categories table in our database, which will play a crucial role in organizing expenses. The SQL command for creating the categories table starts by defining the table's name followed by several fields. We begin with an id, assigned as a serial primary key, which ensures each category has a unique identifier that auto increments with each addition. This is fundamental for maintaining the integrity of our database. Next, we define a name column, which is a varchar 255 type that cannot be null. This will store the category's name, allowing users to quickly identify what each category represents. Lastly, we add a color column designated as varchar 7 to hold color codes that will enhance the visual representation of categories in the user interface. This field is particularly useful for color coding expenses in reports or dashboards, making the application more user-friendly and visually appealing. Now let's take a look at the expenses table structure, which connects each expense to its respective category. Similarly, we start by declaring the table and defining an automatically incrementing id as the primary key. We then include a description column for details about the expense, ensuring that it is not null. The amount column uses the decimal 10(2) data type, allowing for precise monetary values with 2 decimal places, which is crucial for accurate financial tracking. The category id serves as a foreign key, referencing the id in the categories table to establish a relationship between expenses and their corresponding categories. Lastly, the created@at column captures the timestamp for when each expense is added, defaulting to the current time, ensuring all records maintain a temporal context, which is essential for analyzing spending trends over time. Now that we have our categories table set up, let's populate it with some initial values to make categorizing expenses easier right from the start. To achieve this, we will use an SQL inset statement. This statement will allow us to insert multiple rows into the categories table with just one command. Next, we will write the following SQL script that includes several example categories such as food, transport, utilities, rent, and entertainment, each of which has an associated color code to enhance visual representation in our application. Each row includes the category name paired with a color value expressed in hexadecimal format, which will be useful for any visual elements designed to represent these categories in your user interface. By executing this script in your database management tool SQL editor, you'll fill your categories table with these sample data entries, enabling clear identification and categorization of expenses. This foundational step is crucial as it sets the stage for effective expense tracking and helps users gain insights into their spending behavior from the very beginning. Now let's implement the form for adding expenses in our expense add view component. This component begins with a template structure that includes a form for user input. We start by defining input fields for capturing the expense description, amount, and category selection. Each input is bound to a reactive view state variable using the vmodel directive, ensuring that any changes in the form fields update the corresponding variables instantly. Next, we set up the addExpense function, which gets invoked upon form submission. This function calls the addExpense action from our Pinia star, passing an object that contains the description, parsed amount, and selected category ID. This action is integral because it manages the logic required to save the new expense record to the database. After adding the expense, we reset the form fields to their initial state, enhancing user experience by clearing inputs for the next entry. Additionally, we incorporate a drop-down menu populated with categories from our star, allowing users to select a category that aligns with their expense. This drop-down dynamically updates as categories are added or modified in the star, making our application robust and user-friendly. Now let's implement the overview component to display the user's expenses clearly and concisely. This VUE.JS component utilizes the template section to define the user interface, which begins with a heading labeled Your Expenses. Following that, we use a v-for directive to iterate through the expenses array and render each expense as an individual item. Each item displays the description, formatted amount, and the date created. The use of the key directive with expensed ensures that Vue's reactivity system can efficiently track and update the list, improving performance and preventing rendering issues. In the accompanying script section, we utilize the computed function from Vue to create a reactive reference to the expenses stored in our Pinia star through the useExpense star function. By doing this, we ensure that whenever the underlying data changes, the component will automatically reflect those updates. This dynamic rendering provides a seamless user experience, enabling users to quickly review their spending habits at a glance. In a real-world application, consider enhancing the visual presentation, perhaps through color-coding the expenses based on their categories for an even clearer overview. As your application grows, consider implementing features that allow users to edit or delete expenses. You can add buttons next to each expense for these actions, and you'd simply offer modal dialogues for input when users want to make changes. Remember, good data organization also involves regularly analyzing user expenses. Here's a very fun coding exercise. Why not implement a simple analytics dashboard? Imagine displaying charts filled with insights like spending trends, top expense categories, and even forecast future spending based on historical data. To facilitate such features, you could employ libraries like VUE.JS to visualize the expense data. In conclusion, implementing expense tracking in your application can significantly benefit users by offering them clarity and control over their finances. Start with a solid database structure, ensure intuitive forms for data input, and provide visually appealing reports on their spending. You now have the foundational knowledge to build an expense tracker from scratch, and I can't wait to see how you'll customize and expand upon these ideas. Remember, financial literacy is essential, and your application is a powerful tool to empower users on their financial journeys. If you have any questions about this lesson or the concepts behind building an expense tracker, feel free to ask. Let's track those expenses and have some fun with Vue. Now let's implement the command to initialize our Quasar project. First, we will use the terminal to run the command npm init quasar. This command sets up a new Quasar project template, providing a streamlined setup process. Upon executing it, you will encounter a series of prompts guiding you through various configuration options. It's an interactive experience that allows you to customize your project settings, such as selecting the UI framework you prefer, enabling EaseLint for code quality assurance, or opting for progressive web app support. Take your time to explore these choices as they form the foundation of your project. Next, we will navigate to the project directory using cd your project name, where you will find a well-organized structure containing essential folders and files for your application. The src folder is particularly important as it houses the core components of your app, including pages, components, and layouts. This structure will aid you in building a responsive expense tracking app with ease. Now that we've set up the project, let's proceed to run the development server with Quasar Dev to see our project in action. It's the next step in bringing our application to life and ensuring everything is functioning correctly. Now let's implement the command to navigate into your newly created project directory. To do this, we'll use the terminal command cd your project name. This command is essential as it changes the current directory to the one you just initialized with your Quasar project. It's akin to entering a room that you have just set up. Everything you need for development will now be at your fingertips. Once you execute this command, you should see the new directory structure, which Quasar has organized for you. The files and folders created will include essential components and resources necessary for your project, allowing you to easily find what you need as you develop your application. This structured setup is particularly beneficial as it keeps your workspace tidy and promotes efficiency. Understanding where each part resides, such as the src folder for source files and the various directories for pages, components, and layouts, is crucial for navigation and utilizing Quasar's capabilities effectively. Next, let's implement a simple and welcoming homepage in our index view file. Now let's see how we can create a basic template for our expense tracker app. We begin by defining a template section that contains a div with some padding, styled by Quasar's utility classes. Inside this div, we'll add an h1 header introducing our application as "Welcome to your expense tracker." This header sets a friendly tone for users. Below the header, we include a p element with a brief description: "Manage your finances with ease by tracking your spending." It's important to convey the purpose of the application clearly. Next, we must ensure that our component is recognized and properly registered within the Vue instance. To do this, we specify the component's name for identification and also prepare it for later integration with other components that we will build, such as our expense input and overview sections. This structure paves the way for a clean, organized codebase and improves maintenance as we expand our application features. Overall, we've just set up a welcoming starting point for users to begin their expense tracking journey. Next, we will implement the Add Expense Vue component that allows users to enter their expense details. This component begins with a template that utilizes Quasar's Q card, which provides a clean and organized layout for our form. Inside the card, we have a Q form that captures user input without reloading the page, thanks to the @submit_prevent directive that prevents the default form submission behavior. The form consists of 3 essential inputs: a description field, an amount field, and a category selector. The vmodel directive binds these inputs to the data properties of the Vue instance. For the category selection, we use QSelect, which allows users to pick from predefined options stored in the category options array. When the form is submitted, the submitExpense method triggers, logging the inputs to the console. This basic functionality provides immediate feedback during development. To ensure a smooth user experience, the resetForm method is also defined to clear the input fields after submission, helping users prepare for their next entry efficiently. With this setup, we create an interactive element that forms the basis of our expense tracking application. Now let's implement the component for the homepage by incorporating the addExpense component we created earlier. In the index view file, we first define a template structure that welcomes the users to the expense tracker and provides a brief description of its purpose. This gives context to the users about the functionality of the app. Next, we import the addExpense component, which allows us to utilize its form directly within the homepage. By adding the addExpense tag inside the template's markup, we integrate the expense input form right into our layout. This makes it easy for users to add their expenses without navigating away from the homepage. In the script section, we ensure that the addExpense component is registered under the component's object. This step is essential, as it signals Vue to recognize and render the add_expense component correctly within this parent component. By tying these elements together, we have successfully created a cohesive experience where users can manage their expenses seamlessly from the homepage. Keeping the code structure clean and organized not only enhances readability but also maintains a dry approach, promoting component reuse throughout the application. Now let's implement the expense list Vue component, which will display the expenses users have submitted. We start by defining a template that utilizes Quasar's QCard for a clean presentation. Within the card section, we provide a header titled Your Expenses. Below the header, we use a VIF directive to check if the expenses array is empty. If it is, a message is displayed stating there are no recorded expenses. Conversely, if expenses are present, we render an unordered list using velse and the v_for directive to iterate over each expense item. Each expense is represented in the list with a unique key, which is crucial for Vue's reactivity. For now, our data is hard-coded in the created lifecycle hook to simulate fetching from a database. We define a simple array of expense objects, each containing an ID, description, amount, and category. This structure sets the groundwork for our component, allowing us to visualize expenses efficiently. Later, we will fetch real data from the database, but for now, this setup provides a solid starting point and showcases the component's functionality effectively. Now let's implement the expense list component, which will display the list of user-submitted expenses in an organized manner. In this component, we start with a template that includes a card layout featuring a header and a conditional rendering for expenses. If there are no expenses recorded, a message will inform the user. If there are expenses, a list is generated using a v_for directive to iterate over the expenses array. Each entry will display the description, amount, and category of the expense, ensuring users can easily see their spending. Next, within the script section, we define the component's name and data function, which returns an empty array to hold the expenses. Importantly, we utilize the created lifecycle hook to simulate fetching expenses by populating this array with dummy data for demonstration purposes. This serves as a foundation before integrating actual data from a database or API. At this stage, we have a skeleton that can easily be expanded to accommodate functionalities like sorting, filtering, or removing expenses, making it a dynamic component that enhances the overall user experience. Now let's implement the following configuration for our Quasar application. The Quasar conf.js file serves as the central configuration point for your Quasar project. Here, we start by exporting a function that receives the application context as an argument. This function returns an object that defines the settings for our application. In the configuration object, we specify the main CSS file to be included, in this case, app.scss, which allows us to manage styles across the application. The framework section indicates that we're enabling CSS additions, which means we can use custom styling for our components, making our application visually appealing. Next, we find the HTML variables property, where we can customize key visual aspects like the header color and text color, applying these styles globally. This feature ensures visual consistency and allows for easy branding. By tweaking these settings, you can experiment with different themes and color schemes to find what resonates best with your users. Finally, we disable support for Internet Explorer, focusing our development on modern browsers. This configuration provides the foundation for a personalized and polished user interface. As you continue to build your application, remember that Quasar also provides a vast array of additional components like dialogues, tooltips, and notifications, which you can integrate for a richer user experience. Each component is intuitively documented at Quasar Dev, making it easy to explore and implement new features. In this lesson, you learned how to set up Quasar, create a structure for your expense tracking application, and implement fundamental features for users to add and visualize their expenses. You not only explored coding but also experienced the joy of creating a project with a clear goal in mind. Going forward, you can enhance your application further by connecting to an actual database, adding user authentication, and implementing analytics to provide users insights into their spending habits. The possibilities are endless when using Quasar, so keep experimenting and building. Thank you for joining me on this Quasar adventure. Happy coding, and I can't wait to see what amazing expense tracker you create. Now that we have Firebase installed, let's set up the configuration file. First, we create a new file named Firebase config.js in our src folder. In this file, we begin by importing the necessary functions from the Firebase library, initialize app and get Firestore. These functions will allow us to set up and connect our application to Firebase. Next, we define a configuration object called Firebase config, which contains essential keys needed to initialize our Firebase application. This includes the API key, project ID, and other identifiers that uniquely connect our application to the Firebase project we created. Once the configuration is in place, we invoke the initialize app function, passing the configuration object as an argument. This step initializes our Firebase app. In tandem, we call getFirestore, linking our app to the Firestore database for data handling. By exporting DB, we make the Firestore instance accessible throughout our application, enabling us to read and write data effortlessly. This lays the groundwork for integrating Firebase's powerful backend capabilities into our expense tracker. Next, we will implement the functionality to save new expenses in our Firestore database by updating the submitExpense method within our addExpense Vue component. First, we import necessary functions from Firebase such as collection and addDoc, along with our previously created Firestore instance DB. Now let's see how we can enhance the submitExpense method by making it asynchronous, allowing it to handle the addition of new expense documents efficiently. Inside this method, we will wrap our logic in a try-catch block for error handling. In the try block, we invoke addDoc, passing in the collection reference to expenses and an object containing the expense details, description, amount paused as a float, category, and creation date. Upon successfully adding an expense document, we log the document's ID to the console, enabling us to confirm the action. Additionally, we call the resetForm method to clear the input fields, preparing the form for the next entry. This structured approach not only adds data to our Firestore but also ensures that we handle potential errors gracefully, promoting a robust user experience. Now that we have our Firebase setup ready, let's implement the functionality to retrieve and display our expenses in the expense list Vue component. We start by importing the necessary modules from Firebase, specifically our Firestore database instance and the functions required to interact with it. Next, we define our component, naming it ExpenseList, and set up its data property, which contains an empty array called expenses. This array will hold the expense data we fetch from Firestore. Now let's utilize the created lifecycle hook to perform our data fetching as soon as the component is created. Inside this hook, we call the getDocs function, passing in the collection reference for expenses. This function returns a snapshot of the documents in that collection. We then loop through each document in the snapshot, pushing an object to our expenses array that includes both the document ID and its associated data. This approach allows our application to dynamically display the expenses stored in Firestore, ensuring that users have real-time access to their financial information. By adopting this method, we leverage the advantages of a NoSQL database, making our expense tracker more efficient and user-friendly. Now let's implement the authentication feature in our application using Firebase. We create a new Vue component called authVue, which houses the entire user authentication process. Within this component, we define a form that captures the user's email and password. The form utilizes the vModel directive to bind these inputs to our component's data properties, allowing for two-way data binding. Next, we'll introduce two buttons that toggle between registration and login modes, enabling the user to either create a new account or log in to an existing one. The critical functionality lies in the handleAuth method, which gets triggered on form submission. Here we utilize Firebase's authentication methods, create user with email and password for user registration and sign in with email and password for logging in. By conditionally checking the state of is registering, the same method effectively manages both actions, simplifying our code structure significantly. Error handling is also crucial, so we wrap our authentication logic in a try-catch block to handle any potential errors gracefully. This way, users receive feedback if something goes wrong during the authentication process, enhancing the overall user experience. Now let's implement the authentication listener in our main.js file using Firebase's onAuthStateChanged function. This function is crucial for managing user authentication states in our application. When invoked, it listens for changes in the user's sign-in status. If a user is logged in, the listener captures their user information, such as the user ID, allowing us to tailor the app's interface accordingly, perhaps by redirecting them to the main dashboard of their expense tracker. Conversely, if no user is signed in, the function allows us to manage the flow by redirecting the user to the authentication page, ensuring that only authenticated users can access their expense data. By placing this listener in main.js, we enable our application to dynamically respond to user authentication changes at any point during use. This approach enhances the user experience by providing seamless access control and maintaining data security. Thus, this foundational piece of code not only manages user sessions but also sets the stage for a more personalized application experience. Now let's see how we can implement analytics features to enhance our expense tracker application. We'll start by importing necessary functions from our Firebase configuration and the Firebase Analytics module. In the Submit Expense method of our Add Expense View component, we will incorporate event tracking to capture user interactions when they add a new expense. This method currently contains the logic for submitting expenses to the Firestore database. We will add a line to log an event using logEvent, where we define a custom event called addExpense. This event captures essential data, including the expense's description, amount, and category, which allows us to systematically track user spending patterns over time. Integrating this analytics feature is critical for offering insights to users and improving their experience as they manage their finances. With this addition, every time a user adds an expense, the application will automatically send this event data to Google Analytics, which we enabled earlier in the Firebase console. This lets us analyze how users are interacting with our app, helping us make informed decisions on future enhancements. Now that we are ready to deploy our application, we need to set up Firebase hosting. First, we will install the Firebase CLI globally by using the command npm install g-firebase tools. This provides us with the tools necessary to interact with Firebase services directly from the terminal. Once the installation is complete, the next step is to log in to your Firebase account by executing Firebase login. This will authenticate your CLI session and link it to your Firebase projects. Now let's initialize Firebase in our project by running Firebase init. During this process, we will be prompted to configure various features of Firebase, including setting up hosting. Here you'll select the appropriate build output directory, which typically is dist for Quasar applications. This is where your production-ready files will be stored. Lastly, we will deploy our application with the command Firebase deploy. This step will upload your files to Firebase hosting, making your expense tracker application live and accessible to users. In this lesson, we started from running our initial application to finalizing it by integrating critical features such as database connections and user authentication. We also implemented analytics to provide users with insights into their spending. By following through with these integrations, you've developed an application that is not only functional but equipped to assist users in managing their financial habits more effectively. In conclusion, while this journey has come to an end, think of it as merely the beginning. The skills you've gained building this application lay the groundwork for future projects. Keep experimenting, learning, and pushing the boundaries of what you can do. The world of development is dynamic and ever-evolving, so embrace the opportunities to grow and innovate in your projects. Happy coding, and see you next time. In this tutorial, we are diving into the exciting world of app development by creating a dynamic quiz application. This project not only involves the basic elements of a typical app, but also includes an admin panel and utilizes WebSockets for real-time interactions between multiple clients. Get ready for an engaging journey as we explore how to develop a fully functioning quiz app. So far, we've covered how to build an expense tracking application using Quasar and VUE.JS, enhancing it with database integration and user authentication using Firebase. Now we will talk about the architecture of our quiz app, starting from setting up a basic front-end using VUE.JS to the backend with WebSockets for live updates. Understanding how to build a quiz app offers a perspective on both server and client-side interactions, making it a perfect project to solidify our knowledge. To begin, let's outline the components we'll need for our app. The quiz app will consist of a front-end that will display questions and multiple-choice answers to users, an admin panel for creating and managing quizzes, and a backend system to handle user data and real-time quiz functionality. For our setup, we will use VUE.JS for the front-end due to its robust capabilities for building interactive user interfaces, and Node.js with WebSocket for managing real-time data. Now let's implement the code for our front-end VUE.JS components that will showcase the quiz application. We start by creating the quiz view component, which is responsible for rendering the quiz questions. This component initializes a data property to hold the quiz title and an array for the questions fetched from the server. We include a method to handle answer selection, logging the selected option for future use. Upon mounting the component, a function is called to fetch the questions from our Express backend, which we will define shortly. Next, we turn our attention to setting up the backend server using Express and Socket.io. After initializing a new Node.js project, we establish a simple express server that serves quiz questions through an endpoint. Sample questions are stored in an array which we can expand later. We also initialize socket.io to enable real-time communication. For now, it logs when clients connect or disconnect. Finally, we'll write the fetch functionality in the quiz VUE component to retrieve the quiz questions. This function will utilize the fetch API to get data from our backend, updating the component state accordingly and ensuring a seamless user experience. Now let's take a look at the quiz VUE component, which is crucial for displaying our quiz questions and engaging users. In this code, we start with a template that features a title for the quiz and a loading state that informs users while the questions are being fetched. When the data is ready, we dynamically generate a list of questions, each accompanied by multiple choice options rendered as buttons. Upon clicking an option, the selected answer is logged to the console, allowing us to track user interactions easily. Next, we define the component's data properties, including a loading state to manage the user experience, the quiz title, and an empty array for storing questions. The selectAnswer method captures user selections while we lay the groundwork for future functionality. Importantly, we introduce the fetchQuestions method, which will eventually retrieve quiz data from our backend. This method is called in the mounted lifecycle hook, ensuring our component is ready for user interaction as soon as it is loaded. Overall, this code forms the foundation of an interactive quiz interface. Next, we will implement the backend logic that will provide our quiz questions through an API. First, we initialize a new Node.js project and install the required packages, Express for handling HTTP requests and socket.io for real-time communication. Now let's create a basic server by setting up an Express application, wrapping it in an HTTP server, and initializing socket.io. We also define a port for our server to listen on, defaulting to 3000, which is standard for local development. Next, we create a sample array of quiz questions containing objects with question text and multiple choice options. We then set up a GET endpoint at questions that responds with these quiz questions in JSON format when requested. This method is crucial as it allows our frontend to fetch current quiz data dynamically. Additionally, we establish a socket connection that logs when a client connects or disconnects, allowing us to handle real-time events efficiently. Finally, we invoke the server to listen for incoming requests on our specified port, and upon the server's initiation, we log a message for clarity, confirming that our server is operational and ready to handle requests. Now that we have our backend server running with a sample set of questions, let's implement the logic to fetch quiz questions from our backend in the fetchQuestions method. This function utilizes the fetch API to send a GET request to the questions endpoint of our server, which returns the quiz questions as a JSON response. Once the data is received, we update the questions data property with the fetched questions and set the loading state to false, indicating that the data is now available for display. In addition, it's crucial to handle any potential errors during this fetching process. We do this by chaining a catch method, which will log any errors encountered during the request to the console, helping us diagnose issues. This approach ensures that our application gracefully informs users about any problems while trying to retrieve data, maintaining a smooth user experience. By integrating this method into our VUE component lifecycle using the mounted hook, we guarantee that the questions are fetched as soon as the component is loaded, setting the stage for dynamic quiz interactivity. Now let's implement the admin panel VUE component, which serves as the interface for managing quiz questions. In this component, we create a form that allows the administrator to input a new question and its multiple choice options. The use of the vModel directive binds the input fields to the new question object in the component's data, ensuring that the entered values are reflected in real time. Upon form submission, the addQuestion method is triggered. This method pushes a clone of the new question object into the questions array, effectively adding the new question to the existing list. Immediately after, the new question object is reset to its initial state, clearing the input fields for the next entry. It's important to note that ideally, the newly added question should also be sent to the backend. While the current setup only manipulates the local state, we will enhance this functionality by making a post request to save the new question in a database in the future. Additionally, the component includes a section that dynamically lists existing questions, which are rendered inside an unordered list, enhancing visibility for the admin. Next, we will write the functionality to send the newly created question to our server. We will update our addQuestion method in the admin panel Vue component to handle this. In this method, we use the fetch API to send a post request to the questions endpoint on our server. We set the request headers to indicate that we're sending JSON data and include the serialized new question data in the request body. If the response from the server is successful, we pause the response as JSON and push the new question to our local questions array to keep the list updated. Subsequently, we reset the new question object to clear the form fields for future inputs. Additionally, we employ a catch block to handle any potential errors, logging them to the console for debugging purposes. Now we need to ensure the server can accept these incoming post requests. In server.js, we will use express.json middleware to parse JSON request bodies. Within the post handler for the questions route, we extract the question from the request, push it to the quiz questions array, and send a response back to the client, including the newly added question. This allows our admin panel to reflect changes immediately. Now let's implement the functionality to send newly created questions to our server. In the addQuestion method of the admin panel Vue component, we make use of the fetch API to send a post request to the server endpoint questions. This request includes the new question object in the body, which is stringified into JSON format. If the response indicates a successful request, we extract the added question from the response and push it into the local questions array, ensuring that the admin can see the newly added question immediately. Afterward, we reset the input fields to prepare for the next entry. Next, we need to set our server to handle this incoming post request. In the server.js file, we first ensure to parse the incoming JSON data by using express.json. Then, we define our post handler for the questions route. This handler takes the question object from the request and appends it to the existing quiz questions array. Finally, we respond with a 201 status code and the newly added question in JSON format, confirming that the addition was successful. With this in place, we've made it possible for admins to dynamically add questions to our quiz application. Next, we will implement the client-side logic to listen for new questions using WebSockets in both quiz Vue and admin panel Vue. First, we import the IO function from the Socket.io client library, which allows us to create a socket connection to our server. In the mounted lifecycle hook, we instantiate the socket connection by specifying the server's URL, which is http://localhost 3000. This establishes a real-time connection for our application. After establishing the connection, we set up an event listener to respond to the new question event emitted by the server. When a new question is added from the admin panel, this event will carry the question data, which we then push to the questions array in our component. This dynamic addition not only updates the list of questions visible on the client side, but also enhances the user experience by ensuring that all users see new questions in real time without needing to refresh the page. Lastly, to maintain good practices and prevent memory leaks, we include a before-destroy lifecycle hook where we disconnect from the socket when the component is destroyed. This ensures that the application cleans up resources appropriately as users navigate through different parts of the app. To wrap things up, we have constructed a quiz application that includes a user-friendly interface for taking quizzes and an admin panel for managing quiz content. We've explored the integration of WebSockets for real-time updates, enhancing the user experience significantly. We started with basic functionalities, then expanded on them as we learned about front-end and back-end connectivity. This project not only strengthens your understanding of how client-server interactions work, but also prepares you for developing more complex applications in the future. In conclusion, don't hesitate to extend this quiz app. You could add features such as scoring systems, timers for questions, and even a leaderboard to track user performance. The possibilities are endless, and building a quiz app is just the beginning of your journey into the realm of application development. Remember to constantly iterate on your work, gather feedback, and don't shy away from experimenting with new ideas. In this lesson, we will dive into the process of setting up our server environment for the quiz application. A strong server foundation is crucial because it's where all the client requests will be handled, allowing us to manage our quiz data efficiently. So far, we've learned how to create a dynamic quiz application that includes both a user-facing front-end and an admin panel for managing quiz content, utilizing VUE.JS for the front-end and Socket.io for real-time interactions. We established a basic structure with components for displaying quiz questions and an admin panel. as well as set up a backend server to serve quiz questions and handle additions via post request. We've implemented functionality to fetch quiz questions, manage them through an admin panel, and introduced real-time updates using WebSockets to enhance the user experience. In this lesson, we will talk about configuring our server environment, utilizing Express and Socket I/O to handle client requests seamlessly. Now let's implement the following code to create a basic server using Express and Socket I/O. In this snippet, we begin by importing the necessary modules: Express for handling HTTP requests, the HTTP module to create our server, and Socket I/O for real-time communication. We then instantiate our Express application and create an HTTP server based on it. Next, we define a simple route that responds with a welcome message whenever the route URL is accessed, providing users with immediate feedback. Finally, we instruct our server to listen on a designated port, defaulting to 3000, allowing our backend to be accessible. This foundation will enable us to manage requests more effectively and pave the way for future enhancements. Now, let's see how we can enhance our server to serve quiz questions. We'll declare an array to store our quiz questions and implement a new GET endpoint that responds with the JSON representation of this array. This functionality allows clients to easily fetch questions, making our application dynamic and interactive. Next, we will establish a post endpoint to handle the addition of new quiz questions, ensuring that our admin panel can submit questions to the server efficiently. By incorporating this functionality, we'll enable real-time updates to the quiz question list, enhancing user interaction and engagement within our application. Now that we're ready to set up our server environment, let's write the code to create a basic server using Express and Socket I/O. We begin by importing essential modules: Express for handling our routing and requests, the HTTP module to create our server instance, and Socket I/O to enable real-time communication. Next, we initialize an Express application and create an HTTP server with it, allowing us to utilize Socket I/O's capabilities effortlessly. Let's define a basic route that responds to requests at the route URL with a welcome message. This serves as a straightforward way to confirm that our server is operational. Finally, we instruct our server to start listening on a specified port, defaulting to port 3000. This sets the stage for handling incoming requests from clients effectively, ensuring that we have a nice entry point into our quiz application server. In this setup, we've laid a firm foundation for building out further functionality, such as serving quiz questions and managing real-time updates as users interact with the app. Next, we will implement a feature to serve quiz questions to the client by creating an array of questions and a new API endpoint. We begin by declaring a constant called quizQuestions, which holds our quiz data in an array of objects. Each object represents a quiz question and includes the text of the question and an array of options for the possible answers. This structured format makes it easy for us to manage and retrieve questions. Subsequently, we define a new route handler using Express for the GET request to the questions endpoint. When a client sends a GET request to this endpoint, the server responds with the JSON representation of the quiz questions array. This design allows the client-side application to fetch quiz questions effortlessly, ensuring that users receive the most up-to-date information from the server. By setting up this structure, we lay the groundwork for a dynamic interaction between our front-end and back-end, ensuring users can access the quiz content as needed, which is crucial for enhancing the overall user experience of our quiz application. Now let's implement the crucial step of adding new quiz questions through a post request. We begin by ensuring we have Express's JSON middleware set up, which allows our server to automatically pause incoming request bodies as JSON. This is essential for handling data sent from the client, ensuring that we can easily work with the new quiz questions. Next, we introduce a new endpoint at questions to handle post requests specifically for adding quiz questions. When a post request is made to this endpoint, we retrieve the new question from the request body and push it into the quiz questions array. This operation not only updates our in-memory data structure, but also allows us to manage our quiz content dynamically. Once the question is added, we respond to the client with a status code of 201, indicating that a new resource has been created, along with the added question itself in JSON format. This straightforward implementation is key for enabling real-time updates and seamless data management in our application, empowering the admin panel to submit new questions effectively. With our server's basic functionality established, let's enhance it to support real-time updates. Now let's implement the following changes to the post request handler. We will modify the code so that whenever a new question is added through a post request, we not only store it in our quiz questions array but also emit a new question event using Socket IO. This event sends the newly added question to all connected clients in real time. By integrating this feature, we enable all users currently accessing the quiz application to receive immediate updates about new questions, thereby enhancing the overall user experience. The extendability of this approach allows for further features, like displaying animations or notifications on the client side whenever a new question is introduced. This is a crucial step in evolving our quiz application, as it underscores the power of real-time communication in web applications, making them more interactive and engaging for users. Now that we're ready to test our application, we will create a client-side script using Axios, a promise-based HTTP client, to interact with our server. First, we will define an asynchronous function called testGetQuestions. In this function, we send a GET request to our server's questions endpoint using Axios. Upon receiving the response, we log the current list of questions to the console, which helps us verify that our server is correctly serving the quiz data. Next, we will implement another asynchronous function named testPostQuestion. In this function, we construct a new question object that includes both the question text and its options. We then send a post request to the same questions endpoint, submitting this new question to the server. Once the server processes the request and adds the question to its list, we log the added question to the console, confirming successful creation. This simple client-side script serves as a quick and effective way to ensure that our server's functionality is working as intended, capturing both retrieval and addition of quiz questions efficiently. Now let's implement the essential functionality for our server by creating a simple set of endpoints in the server.js file. We begin by establishing an array named quizQuestions to hold the questions for our quiz application. This array will serve as our in-memory data store for the duration of the server's runtime. Next, we define a GET endpoint that allows the client to retrieve the current quiz questions. When the client sends a request to questions, the server responds with the complete list of questions in JSON format, making it easy for the client to display this data. Moving on, we need to allow the admin panel to add new quiz questions dynamically. To facilitate this, we set up an express middleware that enables the server to pause incoming JSON requests. We then create a post endpoint at questions, where new questions can be submitted. This endpoint extracts the new question from the request body, appends it to our quiz questions array, and sends a confirmation response back to the client, indicating the newly added question. Finally, to enhance real-time communication, we integrate socket.io by emitting an event every time a new question is added. This ensures that all connected clients are notified instantly of any new additions, maintaining an interactive and seamless user experience within the quiz application. Now that we have our server environment set up and tested, let's briefly review what we have accomplished. We created a dedicated server environment for our quiz application using Node.js, Express, and Socket.io. This server handles requests for fetching quiz questions, adding new questions, and allows real-time communication for updates. You've witnessed how setting up a server can seem daunting at first, but by breaking it down into manageable steps, it becomes an intuitive process. And just like that, you've got your own server running, ready to handle the requests from clients. As you move forward, feel free to tweak the server logic, add security features, or improve the data handling processes based on your requirements. Establishing a robust server foundation is key, and now that you have this in place, you can easily build upon it. In the next lessons, we will continue to enhance the quiz application, focusing on refining the user interface, adding additional features, and possibly integrating a database to store our quiz questions persistently. You've done a fantastic job so far, and we're just getting started. And with that, our app is complete. You should now be able to complete the quiz with one or more players at the same time. In this final segment, we'll delve into the finishing touches of our quiz application, ensuring everything runs smoothly for users, whether they are playing solo or with friends. So far, we learned how to set up a server environment for our quiz application using Node.js, Express, and Socket.io. We established basic server functionality to handle GET and post requests for managing quiz questions, while also enabling real-time updates for a dynamic user experience. Additionally, we created a simple testing client to verify that our server responds correctly to requests. Moving forward, we'll focus on refining the user interface and adding finishing features to our app. Now let's take a look at how we can create our quiz component using VUE.JS. This component starts with a template that organizes the layout effectively. At the top, we display the current question's text dynamically using template interpolation. Beneath it, we present the answer options as buttons, which are generated through a loop that iterates over current question options. Each button is equipped with a click event that triggers the check answer method when an option is selected. Next, we define some data properties within the component, including useAnswer to track the user's selected answer and feedback message for displaying immediate feedback. The check answer method compares the selected answer with the correct one, updating the feedback message accordingly. This conditional response enhances user engagement, providing either confirmation of a correct answer or an encouragement for mistakes. Furthermore, the feedback is rendered conditionally, appearing only after an answer is submitted. To ensure a polished look, we also include styles that center the content and add spacing around the buttons and feedback messages, creating a user-friendly interface that keeps participants interested throughout the quiz. Now let's see how we can implement the results component that provides feedback to players at the end of the quiz. This component is structured with a template where we display the results to the user. It includes a title and a paragraph showing the score alongside the total number of questions, making the feedback clear and concise. The use of used template syntax like score and total questions allows us to dynamically insert values that are passed as props into the component. Next, we include a button that triggers a restart of the quiz by emitting a restart event. This feature encourages users to engage with the quiz multiple times, enhancing user retention and enjoyment. Additionally, we define the props for the component to ensure it receives the required data correctly from its parent component. The styling is scoped to the results component, allowing us to center the text, which contributes to a clean and focused display. By providing this results summary and a clear call to action button, we enhance user experience and give players the ability to easily replay the quiz. Now let's implement the main quiz application component that will manage the quiz flow and user interactions. In this component, we start by defining our template, which conditionally renders either the quiz component or the results component, depending on whether the quiz is finished. This setup uses Vue's VIF directive to display the active question and gather responses or show the results summary once the quiz is complete. Next, we move into the script section where we import the necessary components and set up our data properties. Here, we define an array to hold the quiz questions, track the current question index, store the user's score, and determine when the quiz has finished. The core functionality lies in the record answer method, which processes user inputs. When an answer is submitted, we check it against the correct answer and update the score accordingly. We also manage the question index, transitioning between questions until the quiz ends, at which point we set quiz finished to true. Lastly, we implement the restart quiz method to reset the quiz state, allowing players to easily retake the quiz. This encapsulation of logic ensures a smooth and interactive user experience throughout the quiz process. Now let's take a look at how we can enhance our server code to support multiple players using Socket.io. This code begins by establishing a connection for each player when they join the quiz. The Socket on join quiz room equals function allows players to join a specific room dedicated to their quiz session. Immediately upon joining, they receive a new question through Socket emit new question get random question, ensuring that everyone in the room gets an engaging quiz experience. Next, we handle answer submissions with Socket on answer question answer room equals. Here, when a player submits an answer, the code checks whether it matches the correct answer generated by get current question. If the answer is correct, we utilize EO2 room emit feedback to send a positive notification to all players in that room, fostering a sense of competition. Conversely, if the answer is incorrect, a different message is sent. This design ensures all players receive immediate feedback on their responses, maintaining an interactive and dynamic quiz atmosphere for everyone involved. Let's explore the deployment process for our quiz application, which is essential for making it available to users. The first step is to create a procfile in the project's root directory. This configuration file is necessary for Heroku as it outlines how to run our application. Specifically, we indicate that our web process will initiate with Node Server.js, signifying the entry point of our Node.js application. Next, we must ensure that all necessary dependencies are correctly defined in the package.json file. This step is crucial because Heroku relies on this file to install the required packages during the deployment. After verifying the dependencies, we can proceed with the Heroku login process through the command line by executing Heroku login. This command will prompt us to authenticate our Heroku account, which is essential for managing our applications. Once logged in, we can create a new Heroku application with the command Heroku create my quiz app. This command assigns a unique URL to our application on the Heroku platform. Finally, we upload our code using git push Heroku main, which transfers our local repository to Heroku. After the deployment process is completed, Heroku will provide a link to access the live application, allowing anyone to enjoy our online quiz experience. Finally, let's consider ongoing maintenance and scalability. Even though you might have everything working perfectly, every application benefits from regular updates and monitoring. Implementing logging on the server side can help you track issues as they arise. You can track user engagement metrics, funnel analytics, or even tweak the quiz gameplay based on user feedback. Always keep in mind that your users are your best asset. Listening to their suggestions and implementing necessary changes can turn a good quiz app into a great one. As we wrap up, remember that a well-designed quiz application has the power to create fun educational experiences for users. With the tools of modern web development at our disposal, no challenge is too large to overcome. You've created a server environment, designed a user-friendly interface, managed real-time interactions, deployed your application, and prepared for future improvements. The path from concept to completion is filled with learning, and your journey doesn't have to stop here. Keep exploring new features, adapting to user needs, and evolving your quiz application into something extraordinary. Congratulations on finishing your quiz application. You've done outstanding work and gained valuable insights into web development along the way. Make sure to keep refining your skills and perhaps even branch out into creating more complex applications. The world is your oyster. Go out there and code something amazing. TensorFlow is an incredibly powerful open-source framework, developed by Google, that enables developers to create and train machine learning models for various applications. Today, we're diving deep into TensorFlow, exploring its inner workings, applications, and how you can harness its power to create intelligent systems. So far, we learned how to create a complete quiz application using Node.js, Express, and Socket.io with real-time updates for multiplayer functionality. We focused on designing an intuitive user interface with VUE.JS, providing immediate feedback to users and showcasing their results at the end of the quiz. Additionally, we discussed deployment strategies on platforms like Heroku and the importance of ongoing maintenance and user engagement for continuous improvement. Now we'll cover the exciting aspects of TensorFlow and how it can revolutionize the way you build applications. First, let's discuss what TensorFlow is and why it has gained such immense popularity in the world of machine learning. TensorFlow offers a plethora of tools and libraries that simplify the process of building and deploying machine learning models. Its flexibility allows it to run on different platforms, from smartphones to servers, making it an ideal choice for developing both small-scale and large-scale applications. But despite its power, TensorFlow can be quite approachable, especially when you break it down into bite-sized parts. Now let's implement the process of installing TensorFlow and verifying its installation. First, we will use Python's package manager, pip, to download and install TensorFlow. This command fetches the latest version of the library and sets it up in your working environment. It's essential to note that TensorFlow is a substantial library, so this step may take a little time as it gathers all the necessary components. Once the installation process is complete, we need to confirm that TensorFlow has been correctly installed. To do this, we'll open a Python shell or script and import the TensorFlow library. By executing a simple command to print the version number, we can verify that everything is functioning as expected. This check ensures that TensorFlow is ready to be used for the creation and training of machine learning models, marking a crucial step in our journey into utilizing this powerful framework. Now let's implement a basic neural network using TensorFlow to classify images from the MNIST dataset. We begin by importing the necessary libraries, including TensorFlow, which provides the tools for building our model, and the MNIST dataset from Keras for our training and testing data. Next, we load the dataset, which is split into a training set and a test set consisting of images of handwritten digits. It's crucial to normalize the pixel values of these images to a range of 0–1. This scaling helps the model learn more efficiently during training. Now let's take a look at how we construct our model. We use a sequential structure where the first layer flattens the 28x28 pixel images into a one-dimensional array. Following that, we add a dense layer with 128 neurons and a Ray-LU activation function, which introduces nonlinearity, enabling the network to learn complex patterns. To mitigate overfitting, a dropout layer is included, randomly setting a fraction of input units to 0 during training. Lastly, we have the output layer, which consists of 10 neurons corresponding to the digit classes 0, 9 and utilizes softmax activation to produce a probability distribution for predictions. After compiling the model with the Atom optimizer and a suitable loss function, we fit the model to the training data for a set number of epochs and evaluate its performance on the test dataset, resulting in the accuracy of our model. Now let's implement a convolutional neural network, CNN, tailored for the MNIST dataset. We begin by constructing the model using the sequential API from Keras, which allows us to stack layers in a linear fashion. Our CNN begins with a convolutional layer that has 32 filters and a 3x3 kernel size, which applies the Ray-LU activation function to introduce nonlinearity. Next, we use max pooling to downsample the feature maps, effectively capturing the most prominent features while reducing dimensionality. Following the first pooling layer, we add a second convolutional layer with 64 filters, again employing the Ray-LU activation function, and another pooling layer to manage the spatial features more efficiently. We then flatten the output to convert the 2D matrix into a 1D vector, which is crucial before we pass the data to the fully connected layers. In this stage, we apply dense layers, the first with 64 units in Ray-LU activation, and the final dense layer with 10 units using the softmax activation function to classify the digits 0, 9. After compiling the model with the Atom optimizer and sparse categorical cross-entropy loss function, we reshape our training and testing datasets to include an extra dimension, preparing them for CNN input requirements. Finally, we initiate the training of the model for 5 epochs, followed by evaluating its performance on the test data. Now let's take a look at how we can convert our trained TensorFlow model into a TensorFlow-Lite format. This step is essential for deploying our machine learning model on mobile apps or edge devices, where resource constraints demand a lightweight version of our model. We begin by initializing a converter with the TensorFlow Lite Converter class, specifically designed to handle Keras models. This enables us to easily translate our model's architecture and parameters into a format suitable for mobile deployment. Next, we invoke the conversion process using the convert method on our converter object, which creates the TensorFlow Lite model. This model is a streamlined version of our original, retaining crucial insights while reducing its physical footprint, thereby enhancing efficiency on less powerful devices. Finally, to finalize this process, we save the converted model to a file with a tflight extension, ensuring it can be easily accessed for deployment. By using the open function in write binary mode, we write the contents of our TensorFlow Lite model to this file. With this lightweight model ready, you can now integrate it into mobile applications or IoT devices, bringing intelligent functionality to users in various environments. Finally, as we wrap up our introduction to TensorFlow, remember that the community and resources around it are vast. With extensive documentation, tutorials, and community forums, help is always available when you need it. You can also explore TensorFlow Hub, a library of reusable machine learning modules that make it easy to integrate pre-trained models into your projects. In conclusion, TensorFlow is an invaluable tool for anyone looking to immerse themselves in the world of machine learning. It opens up a myriad of possibilities for building intelligent applications that can analyze data, predict outcomes, and learn from experiences. So far, we have covered the basics of object recognition with TensorFlow, including setting it up, creating neural networks, and even deploying our models. We are just scratching the surface, and there's a lot more to explore as you further your journey into machine learning with TensorFlow. Keep experimenting, and who knows, the next fantastic application might just be yours. Now let's implement the code to capture video from our webcam using OpenCV. The first step involves initializing the video capture by creating an instance of the video capture class, which will access the default camera configured on your machine. Inside the infinite loop, we'll read each frame from the camera using the read method. If there's an issue with grabbing the frame, the loop will break, preventing further processing. Next, the imshow function displays the retrieved frame in a window named Video Stream. This allows us to visualize the camera feed in real time. To provide user control, we include a condition to check if the Q key has been pressed, allowing the user to terminate the video capturing gracefully. Once the loop exits, we ensure to release the camera resources and close any open windows to properly clean up. This foundational setup lays the groundwork for integrating object detection algorithms as we proceed further in our tutorial. Now let's implement the SSD MobileNet model for object detection. First, we import TensorFlow and NumPy, which are essential libraries for our task. We then load the pre-trained SSD MobileNet model from the specified saved model directory. This model has been trained on a large dataset and is well suited for detecting various objects in real time. Next, we define a function named prepareFrame, which takes a frame as input and converts it into a format suitable for our model. Specifically, it uses tf convert to tensor to change the frame into a tensor, and it wraps the tensor in an additional dimension. This extra dimension signifies the batch size, an important requirement for TensorFlow models to effectively process the data. By getting our frames into the correct format, we are setting ourselves up to receive accurate detection results when we pass these prepared frames to the model. This preparation step is crucial in ensuring that the model can optimize its performance and deliver precise detections as we continue to build out our object recognition application. Next, we will write the following code to integrate video frame capture with our object detection model. The while true loop allows us to continuously capture frames from the video stream. Inside the loop, we first read the current frame using video capture read, and if no frame is retrieved, we break out of the loop. The captured frame is then prepared for the detection model by passing it to the prepareFrame function, which formats it appropriately. After preparing the frame, we invoke the model for object detection, obtaining the results in the detections variable. We then process the detection results by iterating through the bounding boxes of detected objects. For each box, we extract the coordinates and scale them to match the original frame dimensions. This ensures that the bounding boxes fit correctly around the detected objects. We visualize the results by drawing rectangles on the frame using OpenCV's CV2 rectangle function, and the processed frame is displayed in a window titled Object Detection. Finally, we allow for real-time interaction by checking for a key press to exit the loop gracefully when the user presses Q. This complete integration embodies real-time object detection capabilities in a video stream. Now let's implement a confidence threshold to filter out unwanted detections and enhance the overall accuracy of our object detection model. In this section of the code, we start by setting a predefined confidence threshold, in this case 0.5. This threshold determines the minimum confidence score that a detected object must have to be considered relevant. We then loop through the detection scores for each detected object in our output. For each detection, we retrieve the confidence score and compare it to our established threshold. When a score exceeds this threshold, we proceed to obtain the corresponding bounding box coordinates for that detection. This allows us to accurately draw a rectangle around the detected object in the video frame. To correctly position the bounding box, we calculate the coordinates based on the current frame's dimensions. By drawing these rectangles only for high-confidence detections, we significantly reduce the number of false positives cluttering our output, thereby improving the visualization and effectiveness of our object recognition application. This targeted approach is crucial for refining the performance of our model in real-time scenarios. Now let's see how we can implement object labeling to enhance the visual output of our detection model. We begin by defining a label map that associates specific class IDs with the corresponding object names, such as person, bicycle, and car. This step is crucial as it allows us to convert the detected class IDs into meaningful labels that can be displayed on the video feed. Next, within the loop that processes detection outputs, we iterate over the detection scores to filter out those below our defined confidence threshold. If the score indicates a confident detection, we retrieve the bounding box coordinates and draw a rectangle around the detected object on the frame. Furthermore, we obtain the class ID for each detection and use our label map to retrieve the corresponding label. This label is then annotated above the bounding box, providing immediate context to viewers about the recognized objects. By incorporating these labels, we enhance our video stream with valuable insight, making it easier to understand what the model is detecting in real time. This incremental improvement not only aids in visualization, but also fosters a better understanding of the model's capabilities and performance during object detection tasks. In conclusion, effectively detecting and recognizing objects in a video stream using TensorFlow requires a thoughtful approach to data input, model selection, and visualization. Today, we equipped you with the foundational knowledge and hands-on coding experience to capture video streams, apply object detection models, process the resulting predictions, and visualize them seamlessly. This powerful combination of technologies opens a multitude of opportunities for further experimental projects, whether in areas like robotics, surveillance, or augmented reality. So far, we've explored how to integrate video stream handling with object detection models using TensorFlow and OpenCV. By loading pre-trained models and filtering detection results, we've enhanced the accuracy and visibility of the detected objects. You're now armed with the skills to dive deeper into advanced features, such as integrating your models with other functionalities, or even training your object recognition models on custom datasets. Keep experimenting, push the boundaries of what you can do, and unlock the full potential of intelligent systems. Our game is now done. Hooray! We've now almost concluded our collection of applications. In this video, we will summarize everything we've learned about game development thus far. We will explore the various stages of the game development process, the tools we've used, and how they fit together to create interactive experiences. Let's dive in. So far, we've learned the fundamental concepts of game design, development workflows, and how to bring together art, sound, and programming. Additionally, we have discussed the various game engines and libraries that facilitate creating games from scratch. Now we will cover some key techniques, including gameplay mechanics, level design, user interface, and optimization strategies that elevate our game from a simple application to a polished masterpiece. Now let's see how we can implement a simple character controller in Unity to handle player movement. The player controller class begins by defining a public float variable for speed, which determines how fast the player can move. Inside the start method, we initialize the rigid body to D component, which is crucial for applying physics properties to our character. In the update method, we capture the player's input using the input getAxis function, storing the values in a vector2 variable called movement. This variable will hold the horizontal and vertical input, allowing us to detect directions in which the player intends to move. Next, the fixedUpdate method executes the movement logic. Unity calls this method at fixed intervals, making it ideal for physics-based actions. We use the movePosition function of our rigid body to D to update the character's position based on the movement input multiplied by speed and adjusted for the frame timing with time-fixed delta time. This approach ensures smooth and consistent movement, governed by the physics engine, thereby enhancing interactions with the game environment and other objects. Next, we will write a simple random terrain generator using Unity's Perlin noise to create diverse landscapes. The terrain generator class begins by declaring public variables for the terrain's width, height, and scale. These parameters allow you to customize the size and smoothness of the terrain directly from the Unity editor, making it flexible for various game environments. In the start method, a new texture2D object is initialized, representing the terrain's texture. Then, a nested for loop iterates through each pixel of the texture. For each pixel, x and y coordinates are normalized by dividing by the width and height, respectively, and then scaled. This normalization is crucial for generating consistent Perlin noise values. The math Perlin noise function generates smooth random values between 0 and 1 based on the scaled coordinates, which represent the elevation of the terrain at that pixel. We then use color lerp to transition between black and white, creating different shades based on the noise sample. Finally, we apply the changes to the texture and assign it to the material of the game object. This setup not only creates a visually appealing terrain, but also allows for easy adjustments and experimentation by tweaking the scale parameter. Now let's implement a simple UI management system that allows us to display the player's score effectively in the game. We'll begin by creating a class called UI Manager, which will handle all score-related functionalities. Within this class, we declare a public variable called scoreText of type text. This variable will serve as a reference to the UI text element where the score will be displayed. Next, we need a private integer variable, score, to keep track of the player's score throughout the game. In the start method, we initialize the score to 0 and immediately update the score display to show the initial score on the screen. This fresh start ensures players see their score as soon as the game begins. Now let's see how we can update the score as players progress. We define a public method called updateScore, which takes an integer parameter points. Each time this method is called, it adds the given points to the current score and updates the score display accordingly. This immediate visual feedback is essential for enhancing player engagement, allowing them to see the impact of their actions in real time. Finally, we implement the updateScoreDisplay method, which modifies the text property of the score text to reflect the current score, formatting it as score, followed by the score value. Now let's implement a simple object pooling system to optimize object management in our game. This code defines an object pool class that enables us to reuse objects instead of constantly instantiating and destroying them, which can be performance intensive. The class begins with declarations for the object prefab, which is the type of object we want to pool, and a QGame object called objectPool that will store inactive objects. The method getPooledObject is responsible for retrieving an object from the pool. If there are available objects, it removes one from the queue and returns it. If the pool is empty, a new instance of object prefab is created, ensuring that we always have an object to work with when needed. Conversely, the returnPooledObject method handles the return of an object to the pool. By setting the object to inactive, we prevent it from being rendered or interacting with physics until it is needed again. This practice not only maintains performance by minimizing instantiation costs, but also helps keep the memory usage of the game stable and efficient. By employing this object pooling system, we enhance gameplay smoothness and responsiveness, particularly in fast-paced game scenarios. Now that we've covered all these dimensions, let's highlight the iterative nature of game development. Building a game is never a one-and-done scenario. It requires continuous testing, refinement, and feedback gathering. Within this cycle, playtesting stands out as a highly valuable step. It's during testing that we discover what players enjoy, what confuses them, and where there are areas for improvement. Feedback can come in many forms, from structured playtesting sessions with friends to community beta tests or polls on game forums. Listening to the community's input can lead to enhancements that drastically improve the gameplay experience. Make sure to incorporate analytics into your game as well. This is key to understanding player behavior and figuring out what aspects of your game need fine-tuning based on actual data. By capturing detailed statistics, developers can gain insight into player engagement, retention, and performance metrics that guide future development. And trust me, it's a game changer. As we wrap up our journey through the game development process, remember that building a game is a delightful blend of creativity and technical skill. Each stage of development adds depth to the project, from initial design concepts to character mechanics, leveling structures, user interfaces, and optimization. The lessons you've grasped about gameplay mechanics, level design, UI, and optimization strategies are all vital building blocks for your game development toolkit. Armed with this knowledge, you're ready to take your ideas and transform them into immersive gaming experiences. Now, as you step forward into your game development adventures, continue experimenting and challenging yourself. Dive into new frameworks, tackle ambitious projects, and most importantly, have fun along the way. There's an entire world of creativity ahead of you, and the only limits are those you set for yourself. Happy game developing. Creating a stunning web application using Nuxt and Storyblok can be an exhilarating journey. In this session, we'll dive deep into the vibrant world of Nuxt.js and Storyblok, laying the groundwork for creating a portfolio that truly shines. So far, we've covered the essential foundations of game development-related topics like gameplay mechanics and user interfaces. Now, we're shifting our focus to building dynamic web applications. Here in this video, we will unpack what Nuxt is, how it functions, and how Storyblok can amplify our content management process. Let's get started. Now let's see how we can implement a simple greeting page in our Nuxt application that utilizes root parameters. In the template section, we create a basic HTML structure that includes a heading welcoming users to the portfolio page, dynamically incorporating the username captured from the URL. This approach not only enhances user experience by personalizing the greeting, but also showcases the ease of using Nuxt.js for developing dynamic pages. Next, we transition to the script section, where we use the useRoot composable function to access the current root's parameters. By destructuring params from useRoot, we can effortlessly extract the username parameter from the URL, allowing us to display it directly in the greeting message. This feature highlights one of the powerful aspects of Nuxt.js, enabling quick access to dynamic content through routing capabilities, making it an appealing choice for developers looking to build interactive applications. Now let's see how we can implement the integration of Storyblok into our Nuxt application. In this code snippet, we start by importing the useAsync Storyblock composable from the Storyblok Nuxt module. This powerful composable allows us to fetch content from Storyblok in an asynchronous manner. We specifically request the content of our portfolio by passing portfolio as an argument along with a configuration object defining the version we want to retrieve, in this case, the draft version. Once the content is fetched, it will be stored in the story variable. This is where the beauty of headless CMS comes into play, enabling us to access the content dynamically. In the template section, we conditionally render the content only if the story variable is defined. We display the title using the story content title property, ensuring that users see the current title of the portfolio. Furthermore, we utilize the VHTML directive to render the HTML content stored in story content body, allowing for rich text formatting directly fetched from Storyblok. This seamless data-driven approach exemplifies the powerful combination of Nuxt and story management with Storyblok. Now let's see how we can set up our Nuxt project to integrate with Storyblok. First, we begin by initializing a new Nuxt project using the command npx nuxi init myportfolio. This command will create a new directory named myportfolio that will house all the files and configurations needed for our Nuxt application. Once the project structure is ready, we navigate into our created directory with cd myportfolio, and then we proceed to install the necessary dependencies, specifically the Storyblok module, with npm install at storyblok/nuxt. This module is essential as it facilitates the communication between our Nuxt application and the Storyblok content management system. Next, we will configure our application to ensure it recognizes and integrates with Storyblok. This is achieved by modifying the Nuxt config.ts file where we define our Nuxt configuration. Here we include the Storyblok module within the modules array. Additionally, we supply an access token, which is essential for authenticating with the Storyblok API, and specify the API options, including the desired region. This setup will enable our Nuxt application to seamlessly manage content via Storyblok's user-friendly interface, making future content updates both efficient and straightforward. Now let's implement some styles to enhance the visual appeal of our portfolio. In this CSS snippet, we define a class called Portfolio Container which provides essential styling to our main portfolio component. By setting a maximum width of 800 pixels and centering the container using automatic margins, we ensure that our content is neatly presented regardless of the screen size. Additionally, we add padding of 20 pixels for breathing room around the content, and we choose the Arial sans serif font to maintain a modern and clean look. This combination of styles is crucial as it not only captures the user's attention but also significantly improves readability, creating an engaging experience. Remember, good styling practices contribute to an intuitive user experience, helping visitors focus on your work without distractions. So, as you style your components, keep in mind the importance of aesthetics and functionality working together to elevate the overall presentation of your portfolio. Now that we have our project set up, let's create some dynamic content using Storyblok. Start by logging into Storyblok and creating a new space for your portfolio. Within this space, create a new content type called Portfolio. You can set fields such as title, description, and body. These act as templates for the various projects you will present in your portfolio. Once you've created the necessary fields, you can start adding entries which will serve as your portfolio items. Each item can hold different data according to your defined schema, making content management super streamlined. When it comes to fetching these entries in your Nuxt application, you can adopt the use of API calls while utilizing Axios to seamlessly fetch your published content, resulting in effortless integration. By combining the storytelling capability of Storyblok and the robust features of Nuxt, you're set to create some stunning web applications. Now let's implement a navigation component to enhance user experience in our portfolio. We start by creating a nav element that will house our navigation menu. Inside this navigation, we include an unordered list, ul, where each menu item is represented by a list item, li. The use of the v-for directive allows us to dynamically generate the list items based on the menu items, array we define in the script section. Each item in this array consists of a name, slug, and link, with the key directive given to ensure optimal rendering performance by uniquely identifying each item. Now let's see how we can bind the Nuxt link component to each item's link property, which facilitates seamless navigation throughout our application. The Nuxt link is essential in our project as it enables client-side navigation, preserving the app's state and improving load times. In the styling section, we apply some basic styles for visual appeal: a dark background for the navigation bar, white text for the links, and padding for spacing, while also ensuring our list items display inline for a horizontal layout. This straightforward navigation setup plays a crucial role in guiding users through the various sections of your portfolio, promoting easy exploration and engagement. As we work smarter rather than harder, let's discuss deployment. Deploying your application shouldn't be a cumbersome process. We will be utilizing Netlify for seamless deployment. After you push your code to GitHub, Netlify can automatically deploy your changes with each new commit. How this works is simple. Set up a webhook in your Storyblok environment, allowing it to trigger a new build in Netlify whenever your content updates. To achieve this, navigate to the Build Hooks section in your Netlify dashboard and create a new webhook. This means anytime you modify content in Storyblok, a build is automatically triggered and your changes become visible to the world without you needing to run manual deploys. Am I right? That's pretty convenient. In conclusion, with Nuxt.js and Storyblok, you are empowered to create dynamic, fast, and engaging web applications that showcase your projects beautifully and effectively. Focus on separating content from design and leverage the API-rich features provided by modern frameworks and headless CMS systems. The journey you take as a developer unveils endless opportunities, and by incorporating such technologies into your toolkit, you can build future-ready applications. Always remember, practice is key. Go ahead, explore, and create your distinct portfolio, showcasing your unique talent and work. Embrace the process, iterate where necessary, and soon enough, you'll have a stunning portfolio live on the web for everyone to see. Thank you for joining this session, and I can't wait to see the amazing projects you all create. Now let's take a look at the structure of our dynamic root file, slug view. This file will serve as the template for each portfolio item, allowing us to access specific project details based on the slug provided in the URL. Within the template, we set up a simple layout that displays the project's title and its content. Using Vue's reactivity, we bind project title to show the title dynamically, and we utilize VHTML to render HTML content safely from Storyblok, ensuring that any rich text fields display correctly. Next, we will implement the script that retrieves the project data. We start by importing the useAsync Storyblok function from Storyblok's Nuxt integration and use root from VueRouter to access routing information seamlessly. We then extract the slug from the current root parameters with const slug root param slug. This slug is essential as it defines which portfolio items data we want to fetch. Now we will use await useAsync Storyblok to make an asynchronous request to fetch data for our specific project based on the provided slug. This line ensures that we dynamically pull in the correct project content from Storyblok, enabling tailored responses for each URL the user navigates to. By using the version draft option, we also ensure that we can retrieve the most up-to-date content as we develop. Next, we will write the code for our portfolio listing page inside the index view file. This view component utilizes the template section to set up our portfolio's main structure. Here, we define a heading for the page and an unordered list to display our portfolio items. Inside the list, the v-for directive iterates through each item in the portfolio items array, which we'll fetch from Storyblok. Each list item uses key to optimize rendering by uniquely identifying list elements based on their slugs. To create navigable links, we use the Nuxt link component to point to the correct project page. The toAttribute dynamically constructs the URL using the slug, ensuring that users can easily navigate to specific projects. Next, we come to the script setup section, where we employ the useAsync Storyblok function. This function asynchronously retrieves our portfolio items from Storyblok, specifically from the portfolio content type. By specifying the version as draft, we ensure we are working with the most up-to-date content. With this setup, our portfolio items will be seamlessly displayed, enhancing user navigation and improving the overall experience on our site. Next, we will write the CSS to enhance the visual appeal of our portfolio listing in index view. First, we center the main heading with a specific margin at the bottom, creating a balanced layout. The ul element has its default list styles removed, giving a clean slate for the list of portfolio items. Each li is designed with a soft gray background, some margin for spacing, and padding for a comfortable clickable area while also featuring rounded corners to soften its appearance. To make the links within each list item stand out, we set the text color to a darker shade and apply bold formatting, ensuring they capture the viewer's attention. Additionally, we add a hover effect that underlines the text, providing immediate feedback when users interact with the links. This effect is not just about aesthetics, it also fosters better user engagement with your portfolio by encouraging exploration. With these styles in place, your portfolio will look polished and inviting, making it easy for visitors to navigate and discover your work. Now let's implement the following command to start our Nuxt application in development mode. By running npm run dev, we engage the local server that allows us to see our application in action right on our machine. This command compiles the code and serves our application at http://localhost 3000, making it accessible in the browser. After executing this command, you can navigate to the portfolio root to verify that our portfolio items are rendered correctly. Testing locally is crucial because it helps us identify functionality, layout, and visual aspects that might need refinement before deploying the application to a live environment. As you explore your portfolio, interacting with the links for individual projects will confirm that each dynamic route is set up appropriately, ensuring a smooth user experience. This simple yet powerful command is vital for assessing how our project behaves as we build it, allowing us to catch any issues that may arise in real time and ensuring that our portfolio showcases work effectively. Now let's see how we can set up our Git repository to prepare for deployment. We begin by initializing a new Git repository in our project folder with the git init command, which creates a Git directory that will track changes to our project files. After that, we use git add to stage all files in our project, preparing them to be committed to the repository. With git commit m initial commit, we save our changes with a message that marks the snapshot as our initial commit. Next, we connect our local repository to a remote one on GitHub using git remote add origin URL, which allows us to share our project with others and collaborate efficiently. Finally, the command git push origin main pushes our local changes to the main branch of the GitHub repository, establishing a link between our local and remote repositories. With these steps, our project's code is now safely stored online, ready for deployment on platforms like Netlify, further enabling automatic updates and seamless integration. This setup is essential for making our portfolio accessible to the world. Remember to update your content on Storyblok carefully. Each time you clinch that publish button, those changes will be reflected swiftly on your live portfolio. Make it routine to revisit both your deployed application and Storyblok frequently to optimize your portfolio and showcase your latest work. In summary, creating a portfolio using Nuxt.js and Storyblok involves setting up dynamic routes, fetching and displaying content, styling for aesthetics, and deploying for the world to see. You now have the tools and knowledge to establish an engaging online portfolio that reflects your uniqueness and creativity. With all this newfound knowledge, it's time to roll up your sleeves and get creating. Your projects are a testament to your skills, and it's your time to shine. Go ahead and share your magnificent work with the world, showcasing your talent in the most accessible way. Thanks for joining me today, and I can't wait to see your fantastic portfolios come to life. Next, let's see how we can implement the main portfolio page that dynamically displays our projects using the project card component we defined earlier. In this template, we start by creating a simple layout with a header that reads My Portfolio. Below this header, we set up a div container which will hold our project cards. We utilize the v-for directive here to loop through the project's data we fetch from Storyblok. Each iteration represents an individual project, allowing us to create a card for it. The key directive is essential as it helps Vue track the elements for efficient rendering. By passing the specific project object into the project card component using project equals project, we ensure that each card receives the necessary data it needs to render correctly. This modular approach not only keeps our code organized, but also promotes reusability and easier updates. If we change the structure of the project card, those updates will automatically reflect in every instance on the portfolio page. Finally, we wrap our styling in a scope style block to ensure that our layout is flexible and responsive, using flex display properties to allow the project cards to wrap neatly as needed. Now let's implement the following code to enhance our project card component with a required demo URL feature. This template defines how individual project cards will be displayed on your portfolio. We start by creating a div container for each project card, which helps structure the layout. Inside this container, we include an h2 tag to display the project title dynamically, using Vue's template syntax to reference the project title data from our Storyblok content. Below that, a paragraph element is used to showcase the project's description, making it easy for visitors to understand the project at a glance. Visual appeal is important, and an im tag provides a spot to show the project's image, again pulling the source from the project image attribute. The use of src syntax binds the image's source such that Vue will reactively update it if the data changes. Finally, we add an anchor tag that uses the href directive to link to the project's demo URL, ensuring it opens in a new tab. This interactive element not only provides a smooth user experience but also encourages engagement by allowing users to view the project's live with a simple click. Next, we will take a look at how to optimize images in your portfolio for better performance and faster loading times. To achieve this, you can modify the image URL by appending specific query parameters. The code creates an optimized image URL by adding parameters that adjust the width, height, and format. For instance, by using the query string w equals 800 and h equals 600 and fit equals crop and fm equals web. The image is resized to a maximum width of 800 pixels and a height of 600 pixels while converting it to the WebP format. This transformation allows the image to load faster, thus enhancing the user experience on your site by making it lighter. Now let's see how we can implement caching strategies to further improve performance. By utilizing the useAsync Storyblok function, we can fetch the projects from our portfolio while simultaneously managing data caching. The code specifies a max age for caching of 1 hour, meaning once the data is fetched, it will be stored temporarily to ensure subsequent requests for the same data load instantly. This results in quicker responses for users, especially during high traffic periods. Such optimization techniques are crucial for maintaining a seamless and efficient user experience on your portfolio site. Now let's implement a crucial piece of our Nuxt application that integrates seamlessly with Storyblok. The code we are looking at retrieves project data from Storyblok for our portfolio. By using the useAsync Storyblok function, we pass in the identifier for our content, in this case, portfolio, and 2 key parameters. The first parameter, version, is set to draft, allowing us to fetch the most current unpublished changes from Storyblok, which is particularly useful during development. The second parameter is the token, which we pull from our environment variables using process.env, storyblok token. Utilizing environment variables is a best practice as it keeps sensitive information, like API keys, secure and minimizes the risk of exposing them in our codebase. This setup enables the application to dynamically fetch the latest data while maintaining security, making it easier to display project information in real time. Consequently, it fosters a streamlined workflow where content creators can update the portfolio without needing to modify the code directly, ultimately enhancing collaboration and efficiency in our development process. Finally, after deploying your project, it's essential to set up monitoring and maintenance to ensure everything runs smoothly. Vercel offers built-in analytics that lets you see your usage patterns, how well your pages are performing, and even insights about your visitors. It's a great way to understand how your site is resonating with your audience. Consider integrating logging and alerts for potential issues that might arise post-deployment. Using services like Sentry or LogRocket can help you track down bugs in real time, enabling you to make quick fixes and keep your portfolio looking its best. As you enhance your content and implement feedback loops through user analytics, aim to regularly update your portfolio. Content freshness is essential in keeping your audience engaged and reflecting the ongoing journey of your skills and projects. In conclusion, mastering the advanced features of Storyblok along with successful deployment strategies allows you to create not just a site but a standout portfolio that reflects your brand and abilities. Integrating optimization techniques for better performance, utilizing the power of a visual editor, and implementing secure deployment practices enable you to deliver a stellar user experience. As you move forward, ensure you keep iterating and updating your content because your portfolio is a living entity. It's meant to grow along with you. Thank you for joining me today. I'm looking forward to seeing how you leverage these advanced features and strategies to elevate your projects. Keep coding, keep creating, and as always, stay curious.